Learn to build an engaging and accessible memory game while mastering essential React concepts, from state management to API data handling. Through hands-on development, you'll create reusable components, implement game logic, and learn important accessibility practices that make your applications inclusive for all users. Io from Scrimba developed this course.
Hello and welcome to this course where we are going to build a memory game. The course here is the end product of my time in the Scrimba Teacher Talent Program, and I am very excited to share it with you all. To build our memory game, we'll use the React framework and the EmojiHub API, and along the way, we will also do quite a bit of work to ensure that the game is fully accessible to any user. Let's take a look together at what it is we'll be building. When the user opens our game, what they'll first see is this form where they are to select a category and a number of memory cards. When they've done that, they click the Start Game button and get to the actual game. Here we have all the memory cards lying face down, and now, of course, the user's, or should we say player's, job is to find all the matching pairs that are hiding on the other side of these cards. So they start clicking and looking for matches, and they go on until all cards are matched in pairs. When they turn the very last card and thereby match the very last pair, a box pops up above the memory cards telling the user that all cards are matched and at the same time giving them the opportunity to play again by clicking the Play Again button. As you can see, the motifs on the memory cards are emojis, and this is of course where the EmojiHub API comes into play. The screenshot you see here is from the API documentation on GitHub, and you can click it to go straight to this documentation. The API offers different options for fetching one or several emojis and for specifying things like emoji category. So the category that we initially ask the user to select in the form is a category of emojis in this API. In this course, we will be studying the following things. React props. How do we pass, receive, and work with props? React hooks. How do we work with some of the most common React hooks? You'll get to practice working with useState, useEffect, and useRef. We will build reusable components. This truly is one of the great benefits of working with React. We can build components that we can use again and again in various different places in our code. We will build a form and practice how to handle and manage form data in React. And finally, as I mentioned in the beginning, we will look into accessibility. Building a memory game where we rely 100% on emojis that are to be matched in pairs, there are some obvious accessibility issues that we will address along the way. Before you dive headfirst into this course, there are a few things that you should already be familiar with. The React basics. So, for instance, when I say passing props or the useState hook, this should not be the very first time that you hear that. Essential JavaScript concepts. This is not a JavaScript course, but we will write quite a lot of JavaScript code. I am going to provide you with hints here and there in the challenges, but I am not going to really teach you any of these essential JavaScript concepts. Therefore, it is a very good idea if you are already familiar with those. You should also be familiar with how to work with APIs. I will assume that you know about promises, fetch requests, asynchronous JavaScript, and things like that, which are necessary tools when integrating APIs into your front-end projects. Though I also want to emphasize that when I say familiar with, I mean familiar with. You're not supposed to be an expert, because if you were, you wouldn't need to take this course at all. If you know about the concepts that I have listed here, but feel like you do need more practice solving small step-by-step coding challenges, you're definitely in the right place. Your teacher in this course is me, Ayo, with the incredibly Danish last name, Bovold, a name that is, unfortunately for me, pretty much impossible to pronounce if you are not Danish from the very beginning. I am a Scrimba front-end career path graduate and former Scrimba bootcamp code reviewer, and since August 2024, I've been working as an IT engineer in a pharma engineering company. If you want to get in touch, feel free to reach out to me on the Scrimba Discord server or on LinkedIn. You can click the links here to get to my profile on each of these platforms. Before we get going with the course, there is one last thing that I want you to know about me. I am an autistic trans person. I'm sharing this with you because I want you to know that I use the gender-neutral pronouns they, them, and also because you can think of me as an example of something which I really love about the world of coding. There is room for everyone here. It doesn't really matter who you are or what your story is. As long as you can code, you're in. Okay, that was enough of me talking, I think. Are you ready to write some code? Well, I take that as a yes. See you in the next Scrim. In order to ensure that you get a head start in this course, I have written some boilerplate code for our memory game. In a minute, I'll walk you through this code and show you how our app is working at this stage. But before I do that, I would like you to take a good look at everything on your own. More specifically, I want you to take a good look at the React code that we have here inside of the app component. And I also want you to look at the 3 components we have out here in the sidebar in the components folder. While you're doing that, it would be great if you write some code comments. Think of these comments as notes you write to yourself to ensure that you really understand what is going on in the code right now. I would also like you to run the code to see how our app plays out in the mini browser. So please pause the Scrim now, take a tour inside the app, and I'll be back with you in just a second to walk you through everything we have. Okay, I hope you took the opportunity to familiarize yourself with the boilerplate code. The first thing I'll do now is to run the code and show you our app. This is our start screen, and all we have here, as you can see, is a heading, memory, and then we have this start game button. The button lives inside of the form component, and when we click it, we get 10 emojis or 5 emoji pairs rendered to the screen. One obvious thing that you probably thought of yourself as well is that right now our memory cards are giving away their value as soon as we start the game. As we saw in the previous Scrim, where I walked you through the functionality of the entire game, our goal is to display memory cards lying face down with a question mark on them so that we don't give away anything about the value they have. But for now, this is what we get when we start a memory game. If we click one of these cards, we get memory card clicked locked to the console, and this goes for each and every card. No matter which one we click, we get the same message locked to the console. If we look at the return statement here in our app component, we see that this is where we control the conditional rendering of the form and the memory card components. We also have a piece of state up here, the isGameOn boolean that is initialized to false, and then the setter function set isGameOn. And then we have these 2 functions, the start game function and the turn card function. The first one of these, start game, is passed through props to the form component here. Inside the form, we receive this prop and pass it further on to the regular button. And finally, the regular button component returns a button where we use a children prop as the content of the button, and we pass the handle click prop to the onClick event handler. The way we start a game right now is simply by flipping the boolean value of isGameOn to true. And we do that right here inside of the start game function. Furthermore, we use the event that we are receiving as a parameter to prevent the default behavior of hitting a button inside of a form element. When the isGameOn boolean is flipped to true, we render this memory card component. It returns an unordered list, and the list items are created up here by mapping over the emoji array. The emoji array is the one that we have up here. It is a hard-coded array of 5 different emojis all occurring twice. Here, we map over the array, and for each iteration, we grab the emoji itself and its index And then we use the index as the key on a list element right here. And we use the emoji as the content of the button down here. Finally, we receive the prop handle click and pass it to the onClick event handler here. The value of the handle click prop is, as you can see down here, the turn card function. And the only thing this function is doing right now is to console log the string MemoryCard clicked. So to summarize, this boilerplate code gives us an idea of what we are aiming for. We want to be able to start a game and turn some cards, but we are far from actually having a functional memory game. So in the rest of this course, our job will be to transform this rather poor imitation of a memory game to an actual game where we can turn and match memory cards. Besides all of the React code that we've looked at now, there are a few more files out here in our sidebar. Inside of this data folder, we have a data.js file. It contains an object with two key value pairs, category and number, and this is the data that we'll use to create reusable form elements. We also have this index.html file. Honestly, there's not much to say about this one. It's just a very basic setup with an app title and the import of Google fonts and so on. And then finally, we have an index.css file. To allow you to focus only on React, I have written all the CSS in advance. That means that your only job when it comes to styling is to use the class names that I tell you to use when you do the challenges. I hope that you really took the opportunity to familiarize yourself with this boilerplate code, because now it's time to move on to the next scrim and start writing some code. See you there. As we saw in the previous scrim, the boilerplate code that we have right now isn't much of a memory game actually, because if we run the code, all we can do is click the Start Game button, we get some hard-coded emojis, and when we click them, we just get this console log, MemoryCard clicked. So in this scrim, we're going to take the first step in order to get some data from an emoji API instead of using our hard-coded array of emojis. That also means that it is time for your first challenge. Give me a second while I paste in the challenge here. There are 3 parts to this challenge. First, you should turn the start game function into an async function so that we are ready to work with promises. Second, use the try-catch syntax and make a fetch request to the emoji API with the URL I'm giving you here, and store the response that you get back in a const called response. Lastly, check if the response is okay and act accordingly. I have described here what act accordingly means, so please read through the challenge text carefully to make sure that you understand all the steps you need to take. I have a hint and a warning for you as well. The hint is remember the await keyword, and the warning is you won't be able to see any of the emojis that you are fetching from the API at this stage. We are merely fetching and console logging. If any of this seems overwhelming to you at this stage, remember that Google is your friend. You will be able to find help when it comes to the async await syntax or the try-catch syntax if you feel unsure of how to use that. So what are we waiting for? Roll up your sleeves, give this your very best shot, and I will be back with you in just a second to show you my solution. Okay, I hope that went well, and if not, don't panic, we will fix this together. First, we want to turn the start game function into an async function. It is as simple as this. We just write the async keyword in front of the function and we are done. Second, we need a try-catch block and we need to do something inside of these blocks. So let's get started with the basic syntax. Here we have our try block and our catch block, and we are ready to put some code in here now. What we want to try is to make a fetch request to this URL. So we say fetch, paste in the URL, we store this in a const called response, and because we're working asynchronously, we need to await whatever is coming back from the fetch request. Now that we have a response, we need to check if it is okay or not, meaning we have to check, did everything go well? Did we get back something that we can work with or not? And we're going to do that inside of an if statement. So we check if the response is not okay, and inside of here, we are going to do some error handling. And if it is okay, we can move on to the next step, which is to get the data from the response, store it in a const, and log it to the console, and then finally call the setIsGameOn function with the Boolean value of true. So we say const data, then we await the response, and we need to use the JSON method on this one. Now we can console log the data, and we can call this function that we have down here. So we got the happy path up and running. If everything goes as we wanted to, this code will be executed. If we run into trouble, on the other hand, we'll need to do something in here. And what we'll do is we'll throw an error. And in the parentheses here, we will add a custom error message. Could not fetch data from API. Down in the catch block, we want to console log this error message, and we do it by receiving it here. And then we say console error and pass in the error. So this should be it for this challenge. Let me just remove all of the text here to buy us some space, open up the console, and let's try to run the code now. We hit start game, and oh no, we got a reference error. I misspelled something somewhere. Let's take a look. Yeah, this is it. Response. Okay, let's try again. Now it's working. The data we get back, as you can see, is an array, and it is a lot of data. And here's an array of objects, and these objects each have 5 key value pairs: name, category, group, HTML code, and Unicode. So our fetch requests seem to be working. We've got the happy path up and running. Now let's check that our error handling is actually working. I'm just going to manually sabotage this URL and then run the code again, start the game, and our catch block is successfully catching the error, so we get our custom error message logged to the console down here. So now that we got some data back from the API, we are ready to move on, and in the next scrim, we are going to store this data in state so that we can work with it appropriately in React. In the previous scrim, we successfully made a fetch request to the Emoji Hub API, and we stored the data that we get back from this request right here in this variable that we simply called data. In this scrim, it will be your job to take a sample from this data and save it in state to make it available to us throughout the entire app. So I hope that you're ready, because it is challenge time for you now. In step 1, I want you to create a new state variable called emojisData with a corresponding setter function and initialize it as an empty array. In step 2, go into the try block of the start game function and create a new variable called dataSample. This dataSample should be equal to the first 5 elements from our data here. In step 3, store the dataSample as emojisData in state. And finally, in step 4, I want you to log emojisData to the console. I would like to give you a hint and a warning as well. In step 2, you can use the javascript.slice method to get the data sample. And the warning here, we are still rendering our hard-coded emojis, so all of the hard work that you're doing right now is not yet visible in the mini browser. Now pause the scrim, do your best to solve this challenge, and I'll be back with you in just a second to show you my solution. Okay, I hope that went well. Let's do this together. We'll start by creating our new state variable up here at the top of the component. We do that using the const keyword. Then we open up our square brackets, type out the name of our state variable, emojisData, and after the comma, we create the new setter function, setEmojisData. Then we set this equal to useState with an empty array as the initial value. That was it for step 1. In step 2, we want to get a data sample from this data variable we have here inside our try block. We'll start by creating the data sample variable itself using the const keyword again. And now we set this equal to data.slice. And inside of the brackets here on our slice method, we specify which element we want from data. And those are the elements between index 0 and index 5. Index 5 will not be included here, so what we'll get is index 0, 1, 2, 3, and 4. That was step 2 done. In step 3, we want to store this new data sample as emojisData in state. So here at the bottom of our try block, where we are also setting isGame on to true, we'll use our newly created setup function, set emojisData, and then inside the brackets, set data sample to be the new value of emojisData. That was it for step 3. Finally, we should console log emojisData. We do that up here right below our state variables, and that should be it for this challenge. Let's run the code and see how we're doing here. As soon as our app component renders for the very first time, we get an empty array logged to the console, which is, as you know, the initial value of emojisData. Now let's click our Start Game button to fetch some new data from the Emoji Hub API. And look at that, we still render hard-coded emojis in the mini browser, of course. But down in the console, we now have an array containing 5 objects. We are successfully fetching the data, getting a sample, and storing it as emojisData in state. Excellent. In the next scrim, we'll start looking into how we can render this data on our memory cards. So when you feel ready for that, I'll see you in the next scrim. In the previous scrim, I promised you that we were now ready to render the API data, the emojis that we get from calling the API, to the mini browser. But I have to admit that that was not quite true. I misled you a bit on this one, because before we can do that, we have to talk about HTML entities. As you may or may not already know, HTML entities are special codes that we use in the HTML to represent reserved characters or characters that are not easily typed on a keyboard. For instance, the code you see here, starting with an ampersand and a hashtag and ending with a semicolon, is translated into that cute little monkey face. Another example of something that you might see more commonly used is the HTML entity representing a copyright symbol. Now, the reason why we have to talk about this now has to do with what I'm about to show you next. HTML entities behave differently depending on how we use them in our code. If we hard code an entity directly into the HTML or the JSX in a React app, we don't have to do anything. The entity is automatically decoded, meaning it is translated automatically into whatever we are trying to display. But on the other hand, if we take this entity and store it in a variable, it will not be decoded automatically, meaning that we have to do something to decode it. Let's take a look at some code to illustrate the issue here. In this very simple React app, I have an H1 and a button. It looks like this in the mini browser. This cute little monkey face is created using the same code as the one I showed you on this slide previously. So the HTML entity here translates into the monkey face. Now, if we take this HTML entity and store it in a variable, you will be able to see the issue here in action. So I have created a const monkey face entity with the same value as the one I have on my button, and now I'm going to display this monkey face entity on a button next to the other one. And when I run this code, this is what we get. We have the monkey face displayed correctly here, and then we have the actual HTML entity displayed here instead of the translation into monkey face. And this is simply because when we store the HTML entity in a variable, we have to decode it. Luckily, we have libraries that can help us do that. The screenshot you're seeing here is from a library called HTML Entities, and the screenshot is at the same time a link to this documentation, and I recommend that you pause the scrim and go there and read through the documentation at your own pace. In short, we are going to use this library to decode the variable when we render it on the button. So the process is this. You won't be able to see everything I do now, so I'll walk you through it. When I hover over this sidebar out here, the 3 dots are showing up for me. I click those, then I say Add Dependency in the drop-down menu. And in here, I type the name of the npm package I want to install. And now you see out here in the sidebar, I now have my HTML entities installed. The next step is to import decode entity from this library. So I say import, and it's a named import, so I need my curly braces. And the import is from the HTML entities. Now I can use the decode entity method on my monkey face entity when I am rendering it. So I say decode entity and I pass the variable into the brackets. If I run the code again now, I should get 2 monkey faces side by side. And I did. So the lesson here is when you work with HTML entities, you need to distinguish between entities hard-coded in your HTML or JSX and entities that you somehow store in a variable. And with our knowledge of HTML entities now up to date, we can move on to the next scrim. Now we are finally ready. No more asides, no more detours. It is time to render our EmojiSData to the mini browser. So without further ado, I will paste in a challenge for you. This challenge comes in 2 parts. Part 1 is that I want you to pass the emojisData that we have saved in state as a prop called data to the MemoryCard component. And just to remind you, the MemoryCard component is this one that we are rendering down here. Part 2 of the challenge is written out inside of the MemoryCard component. Here, I want you to receive the data as a prop, and I want you to use this data to render the emojis that we fetched from the API. Remember that the data is an array of emoji objects. So what you could start out by doing is logging the data to the console to see what property on this object that you should be rendering as the content of the button. I do, of course, have a hint for you as well. You know how to decode HTML entities, and if you look closely at the sidebar to the left, you will see that I've been so kind as to already install the necessary dependency for you. So what are we waiting for? Please pause the scrim, jump into the code, and get those emojis rendered to the mini browser. I'll see you back here in just a second and show you my solution. The first part of this challenge should not cause too much of a headache. We want to take the emojisData and pass it as a data prop to the MemoryCard component. So we go down here and say data, and we simply pass the emojisData. And that is it for part 1 of the challenge. Inside of this MemoryCard component, we start out by receiving this prop. So I add it up here, and let's console log it to remind ourselves what it is we are receiving. So we run the code, we start the game, open up the console, and let's inspect this for a while. Since you know everything there is to know about HTML entities, you hopefully figured out that what we need here is the HTML code, which comes in the form of an array. All of these simply have one item in that array. Other parts of the data from the API has 2 items in the array, both of which are HTML codes. So we will settle with just always grabbing the first item in the HTML code array. So the next step here is to swap this emoji array for the data that we are receiving. We still want the emoji as well as the index, and we can leave everything as it is except for this part. The emoji here represents each object in the data array. So on each emoji, we want the HTML code. And since it's an array and we want the first item in that array, we will add square brackets and 0. Now, if we render this as it is, we will get the actual HTML code instead of the emoji represented by this code. So we also need to decode this entity. So up here at the top of our file, we'll import the decode entity from the HTML entities library. With that in place, we can now use the decode entity method down here. So we'll wrap this in brackets and say decode entity. Let's just close the console. Now, hopefully, everything is working now. We've done all we need to do. So we can delete the challenge text. We can delete the console log. We can delete the hard-coded emoji array and run the code. So we start the game and we get the emojis that we fetched from the Emoji Hub API. If you manage to figure out all of this on your own, give yourself a pat on the back. That is an amazing job you just done there. Take a minute to celebrate or get some fresh air if you need to, and I'll see you in the next scrim. Now that we are finally rendering memory cards with the emojis that we fetched from the API, you probably realized that there is one obvious issue here. We are rendering 5 unique emojis, not 10 memory cards with 5 emoji pairs on them. And frankly, that is pretty useless in a memory game where the whole point is to find and match pairs. To fix this issue, we'll have to write quite a lot of JavaScript code in our app component, and we will break this down into multiple steps and multiple scrims. But before we start writing any new code, let's talk about, in plain English, what exactly it is we need to do here. First of all, a memory game requires matching pairs, so we need to duplicate each unique emoji. Second, just like you would shuffle a deck of cards before playing a card game, we have to shuffle our emojisData in order to display the memory cards in a random order. It would simply be too easy and thereby also rather boring to play the game if the matching cards were always in the exact same positions. Both of these things are essential. Without shuffled pairs, there simply is no memory game. Though I would like to add a third task to our to-do list here, and that is to randomly select 5 emojis from our API data so that we don't always display the same 5 emojis on our memory cards. This is not something that we strictly have to do, but I think it's a nice touch to create variation in the game now that we have loads of emojis available to us in the API. The next question that we have to ask ourselves now is, in what order should we do all of this? Well, logically, we have to start out by getting random emojis from the API data. So let's move this one up. We place get random emojis from API at the top of our to-do list and call it step 1. After getting these 5 random emojis, we then want to duplicate each of them. So we can leave this step here, duplicate unique emojis, and call it step 2. The third and final step will obviously be to shuffle the emojisData. Okay, so this is what we have to do. Step 1, get random emojis from API. Step 2, duplicate unique emojis. And step 3, shuffle emojisData. In the next scrim, we'll start working on step 1, so whenever you're ready, I'll see you there. As we established in the previous scrim, the first thing we have to do when we want to go from rendering 5 memory cards with 5 unique emojis on them to instead render 10 cards with 5 randomly selected emoji pairs is to actually get these 5 random emojis from our API data. Up until now, we have worked with this data sample here, which is an array of the 5 first emojis that we get back from the API. We use the .slice method and thereby the indices of the emoji objects in the data array to get this data sample. The question that we have to ask ourselves now is, how can we get emojis at random indices in the data array instead of always getting the first 5? And actually, I want to give you a second to try to come up with a strategy of your own before I tell you how I intend to solve this one. So I've created a mini challenge for you. Here it is. I want you to try to come up with an answer to the question I just asked you. How can we get emojis at random indices in the data array instead of always getting the first 5? Pause the scrim now, give this some thought, and return to me to hear my answer to this question. Okay, how did that one go? Do you have any ideas for how to do this? No matter what, I'll share my strategy with you now. We are going to generate 5 random numbers and then use these numbers as indices to get random emojis from the data array. So far, so good. But how do we know if the random numbers that we generate can actually be used as indices? I mean, what if we generate numbers that are too large to work as indices in our data array? Just to give you an example, if we had an array of, say, 10 items and then randomly generated the number 47, we wouldn't be able to use that as an index. I want you to think about this one as well, so here is another mini challenge. Try to answer this question here. How can we get random numbers within a range that allows us to use them as indices in the data array? Pause the scrim, give this some thought, and I'll be back with you in just a second to give you my answer. Any ideas? Here is my strategy. We have to ensure that the range of these 5 random numbers is the exact same as the length of the data array. Okay, I hope that these initial problem-solving exercises got you warmed up, because now it's time for you to get your hands on the keyboard again. In step 1 of this challenge, I want you to create a new function called getRandomIndices right here below the startGame function. It should receive data as a parameter, and we'll get back to in a second what data is in this context. In this new function, you should declare a new variable called randomIndicesArray and initialize it as an empty array. After you've declared this variable, meaning right below it, you should use a for loop to generate 5 random numbers within a range equivalent to the length of the data array and push these numbers to randomIndicesArray. And then finally, return randomIndicesArray at the bottom of the function. Finally, I want you to go into the try block of the startGame function and log the return value from getRandomIndices to the console, passing data to it as an argument. So just to be completely clear, when you call the getRandomIndices function inside the try block, the data you're passing is this one here. It's the data that we get back from the fetch request to the API, and therefore, obviously, the data parameter that the function should receive, as I described in step 1, is this same data. I want to give you a hint as well. We want exactly 5 unique random numbers. So what can you do inside the for loop to ensure that we'll actually get that? Pause the scrim now, do your very best to solve this challenge, use Google and ChatGPT if you need to, and return to me to see my solution. Okay, I hope that went well. Let's do this together. We'll start by creating our new function here. And we know that this function should receive a parameter called data. That was step 1. Inside the function, the first thing we want to do is to declare a new variable called randomIndicesArray. We'll do that using the const keyword, and we'll initialize this variable as an empty array. That was step 2. Now to the for loop, which was probably the trickiest part of this challenge. We'll start by saying for, then open up the brackets, and then let I equal 0. This means that on the first iteration through this loop, I is equal to 0. Now we want to specify how many times we want the loop to run. We want 5 random numbers, so we want the loop to run 5 times, and therefore we say I is less than 5. And finally, we increment I by 1 for each iteration. So we say I plus plus. Inside the loop, we want to generate random numbers. We can do this by declaring a new variable. I'm going to call this one randomNum, and set this equal to a random number within the range of the length of the data array. To do that, we'll use JavaScript's math.random method. This method generates random decimal numbers between 0 and 1. We know that decimals are of no use to us as indices, so we'll start by flooring this. So we wrap this in brackets, and then before the brackets, we say math.floor. This would give us a random number which is always 0, because a floored number between 0 and 1 will always be rounded down to 0. So now in order to get random numbers in a range that is equivalent to the length of the data array, we're going to say math_random multiplied by data.length. Now we've got our 5 random numbers and we want to push those to the random indices array. Though we want to make sure that each of these numbers are unique, so we need to check that the number that we are currently pushing is not already in that array. To do this, we create an if statement, and the condition that we want to check for is if random indices array includes random num or not. So we can use the exclamation mark, then say random indices array dot includes, and in the brackets here on the includes method, we say random num. So only if the random indices array does not include the random number, we'll push random num to random indices array. But what happens then if just by chance we generate the same random number twice? Let's say we generate the number 20 2 times. Then the second time this for loop generates the number 20, nothing will be pushed to the array and we'll just move on to the next iteration. So our random indices array will end up containing 4 unique random numbers, not 5, because one of our iterations just led to nothing. So to ensure that we don't end up in a situation where our 5 iterations generate less than 5 unique random numbers, we need an else statement here as well. And what we'll do here is that we'll subtract 1 from I. This way we can be absolutely sure that if the random number that we generate up here is not pushed inside the if block to the random indices array, because the same number is already in that array, then we'll create an extra iteration in our for loop by subtracting 1 from I, because it's the value I up here that determines how many times this loop will run. So that was it for the for loop. Now we simply have to return random indices array from this function. And this was step 3 done. The last thing we have to do now is to go up here inside the try block and console log whatever is returned from getRandomIndices. So we write a console log, and inside of this one, we call the function, passing it data as an argument. This should be it. So let's delete the last part of the challenge. Now we open up the console, run the code, and start the game to invoke the start game function and thereby invoke our new getRandomIndices function. And down in the console, we get an array of 5 random numbers. Right now, they are in the range between 5 and 77. Let's just do the same thing again to see what other numbers we can get here. This time, we got values between 14 and 97. Let's go just one more time. Now we are in a range between 17 and 100, so we clearly have a lot of data here. At least 100 different emojis. Okay, great. Now we have some random indices to work with, and in the next room, we'll use these random indices to actually get 5 random emoji objects from the API data. When you're ready to tackle that, I'll see you there. In this scrim, we are going to use our newly created getRandomIndices function to get a data slice of 5 randomly selected and unique emojis from the API data, and we'll also display these emojis on the memory cards in the mini browser. So if we look at our to-do list again, you can see that we are still dealing only with step 1 here. To complete the task at hand, we need to create another brand new function, and we also need to write some more code in the start game function. There are quite a few steps to this, though I believe that you can do it, so let's just get going with your next coding challenge. First, below the start game function, I want you to create a new function called getDataSlice. The function should receive data as a parameter, and this data is the exact same as the one we were dealing with in the previous scrim. The data variable up here that we get from calling the JSON method on our response. Inside this new function, make a call to get random indices and store the return value in a new variable called random indices. In step 3, map over random indices and use the random numbers stored in this array to create a new array of random emojis selected from data. Store this new array in a variable called dataslice and return it at the bottom of the function. Inside the try block of the start game function, make a call to get dataslice, passing data as an argument, and save the return value in a variable called dataslice. Then delete the data sample variable and replace data sample with the new data slice variable in the setEmojisData function. Finally, when you've done all of this, run the code and start a new game to check that your code is working. And how do you know if it's working? Well, you should see that in our mini browser, where we currently have the 5 first emojis that we fetch from the API, you should instead see 5 memory cards with 5 randomly selected emojis. Now do your best to solve this challenge, and I'll be back with you in just a second to show you my solution. So how did that one go? I hope you managed to solve the challenge, and if not, don't panic, we'll go through everything together now. First of all, we need to create a new function. I'm going to do that right here below the start game function and the challenge text. Our function should be called getDataSlice, and it should receive data as a parameter. That was step 1. In step 2, we want to make a call to get random indices. As you know from the previous scrim, getRandomIndices receives data as a parameter, so we of course have to pass data as an argument when we make the function call. And then we store the return value from this function call in a new variable that we call randomindices. Now we're done with step 2. On to step 3. Here our job is to create a brand new array of random emojis selected from data, and we do that by mapping over random indices. So we say randomindices.map. Now we have to decide what we want to call the items that we are mapping over in this array. I am going to call these items index because we're going to use each and every one of these random numbers as indices. Then we create the arrow function here, and what we have left to do is to use index on the data array. So we say data, square brackets, index. This operation here gives us a new array that we want to store in a variable called dataslice. Finally, we want to also return this new dataslice variable from our function. If we wanted to, we could actually write our code in a slightly different way here inside of our getDataSlice function. Let me show you. Instead of saving the new array in a variable called dataslice and then return dataslice, we can actually just return the entire expression here. This is very concise code. It looks really professional, but in my opinion, it is a bit less readable than what we were doing before, where we named this new array dataslice and returned that dataslice variable. I think it's easier to see what's going on here, which is why I personally prefer this solution. Now on to step 4. Inside the try block, we want to make a call to get dataslice, passing it data as an argument. The return value from this function call is the dataslice array that we just created, so now we're going to store it in a variable that we again call dataslice. That was step 4. Now in step 5, we have a bit of cleaning up to do. We no longer need the data sample variable, so we can delete that one. And since data sample here no longer exists, we want to replace that with dataslice. The only thing we have left to do now is to run the code, cross our fingers, and hope that everything is working. So I'll delete this last bit of the challenge, run the code, and start the game. And look at that. These emojis are brand new to us, and that's because we just successfully fetched random emojis from the Emoji Hub API. Our next task is to tackle step 2 and 3 on our to-do list, that is to duplicate and shuffle these emojis so that we actually get 10 cards with 5 emoji pairs on them rendered to the menu browser. And this is exactly what we'll be doing in the next scrim. When you're ready to move on, I'll see you there. In the last 2 scrims, we worked on step 1 in our to-do list and built the logic for selecting random emojis from the emojisData that we fetch from the Emoji Hub API. Now it is finally time to complete step 2 and 3. So in this scrim, we're going to write a function that duplicates and shuffles our randomly selected emojis. Once again, I'll do a bit of work for you and make some changes here in the app component before I give you a challenge. Okay, let's take a look at these changes together. Down here, below the getRandomIndices function, I have created a new function called getEmojisArray. This function receives a parameter called data. The call to this function is made up here inside of our start game function. When we call getEmojisArray, we pass it data slice as an argument. As you know, data slice is an array with 5 randomly selected emojis from the Emoji Hub API. Then we store the return value from getEmojisArray in this variable called emojisArray. And finally, in the setter function down here, we set our emojisData to be this new emojisArray. Just as in the previous scrim, this code is currently broken because there is no return value here in our getEmojisArray function. And therefore, we cannot, obviously, store a return value in a variable. So it will be your job now to write the code that we need inside the getEmojisArray function to get our code up and running. Here is what I want you to do. In step 1, you should create a new variable called pairedEmojisArray. This variable should be an array that includes each object from the data array twice. And remember, data is an array that we're receiving as a parameter, and it is equal to the data slice. And when I say that each object should be included twice, that is, of course, because this is where you're going to duplicate each unique emoji. In step 2, I want you to use the Fisher-Yates algorithm to shuffle pairedEmojisArray and finally return this array at the bottom of the function. In step 3, you should simply run the code and start a new game to check that your code is working. I do have a couple of hints for you as well. In step 1, you can use the array spread operator to create a new array. And in step 2, you should Google the Fisher-Yates algorithm. You're not supposed to know this algorithm by heart. You're not supposed to be able to just type it out from memory. I can't do that either. You'll see that later when I walk you through my solution. So Google it. All right, pause the scrim, do your best to solve this challenge, and return to me to see my solution. So I hope that went well. Let's get to it. We'll start by creating the new variable pairedEmojisArray using the const keyword. What we want to assign to this variable is a new array, and inside of this array, we want every object from data, but we want to duplicate them, and we want objects. We don't want any nested arrays in here, and that is why we're going to use the array spread operator. So we spread in the data, and this gives us basically just a copy of the data array because we're spreading in everything inside data into this new array that we call pairedEmojisArray. So now that we want every object to appear twice in the array, what we do is simply that we spread these objects in twice. So we add a comma here and then do the exact same thing again. We spread in the data. That was step 1. In step 2, we are to use this Fisher-Yates algorithm, and I'm now going to do something that you'll never see me doing again in this course. I'm going to copy-paste a lot of complicated code and not go through it in detail. Just give me a second. Here it is, the Fisher-Yates algorithm that shuffles items in an array so that we get them in a randomized order. You really don't have to understand exactly what's going on inside of this for loop, because that is way beyond the scope of this course. All you have to know is that you can use the Fisher-Yates algorithm to shuffle arrays. On the other side of this for loop, When we have run paired emojis array through it, we have an array with duplicated emojis in a randomized order, so all we need to do now is to return this array. And that was step 2. Finally, we are to run the code to see how this went. I'll delete the challenge text, run the code, and now to the moment of truth. We start a new game and hopefully we see 10 memory cards, 5 emoji pairs in a shuffled order. Look at that, we made it! I don't know about you, but I am really happy about this now. This memory game is going to be awesome. I imagine that solving step 1, 2, and 3 on our to-do list was hard work. So please remember to take a break, to not wear yourself down completely. And when you're feeling refreshed, I'll see you in the next scrim. Before we push forward building out the logic of our memory game, I need to take a moment to address a few discrepancies in our code that will reveal themselves in the next scrim. You see, the 3 scrims that you just watched were re-recorded after I finished recording everything else, and the reason for this is that I discovered 2 issues in the code that I wanted to fix. Though unfortunately for me, recordings show no mercy, as you know, so what you'll see in the rest of the course is the code as it looked before I discovered the issues. Let's take a look at these 2 issues one at a time. Inside our start game function, I have now added the await keyword before 2 of our function calls here, and I have also made the functions themselves asynchronous. So down here, we have the async keyword in front of the getDataSlice function, and the same down here, the async keyword before getEmojisArray. This is what you'll see in the rest of the course, though the thing is, it's not actually necessary for these functions to be async. The code here works perfectly fine. It does not break anything to use the async await syntax on functions that can run synchronously. The only issue with this is that it adds an unnecessary layer of complexity to the code and makes it a bit harder to read and understand. To give you a chance now to learn from my mistakes, let me explain why these 2 functions don't need to be async. The start game function itself must be async because we are indeed performing asynchronous operations inside the function body. We have to await the fetch request here on line 13 before we proceed to check the response in line 15. We also have to await the JSON method that we call on the response down here on line 19 before we can store the API data in the data variable. Though now that we have the data safely stored in a variable, we no longer need to await anything. The rest of our code here can run synchronously, so there's just no need for awaiting these functions to do their thing. The second issue I discovered is again not about broken code, but rather about unnecessarily complex code. As you probably remember, here in the getDataSlice function, we use the .map method on random indices to create a new array of randomly selected emojis. Though, as you can see here, that super neat solution that allowed us to write everything in one single line has now been replaced with 4 lines of more complex code. Here I use the .reduce method to sort of manually achieve what the .map method gives us right out of the box. It works as intended, nothing is broken, but it is kind of like reinventing the wheel. It's not incorrect, it's just unnecessarily complex. Moving forward in the course, the code will look as it does here in this scrim, so just remember, if you at some point need a reminder of what is going on at this part of our code base and how everything works, then go back and re-watch this and the 3 previous scrims. Okay, with this out of the way, we can move on to our next big task, which is to build the logic for turning or selecting memory cards. When you're ready for that, I'll see you in the next scrim. Up until now, we have made a lot of hard work related to starting a memory game and rendering our memory cards to the mini browser. Our next big task is to figure out what should happen when we click a memory card. Down here, at the bottom of the app component, we already have a turn card function set up. This function is passed as the value of the handle click prop to the MemoryCard component, right here. We obviously want this turn card function to do something else and more than just logging the string MemoryCard click to the console. But before we can start writing any new code, there's something we need to consider. Therefore, I have prepared this mini challenge for you. I want you to think about what information on a memory card we can use to 1. Identify which card was clicked, and 2. Identify matching emoji pairs. You shouldn't have to write any new code to solve this challenge, but I highly encourage you to console log the emojisData to see what we have to work with. Please pause the scrim now, do what you have to do to come up with answers to these 2 questions, and return to me when you think that you've got it. Did you figure it out? The answer to question number 1 is the index. And the answer to question number 2 is the name of the emoji. To illustrate why that is, we'll take a quick look both at the app itself and at the emojisData. Due to the nature of a memory game, there are no unique values on the emoji objects that we render here. Every unique emoji is duplicated and appearing twice on the screen. So the only way that we can tell this cat from the next cat over here is by looking at their position. And the position is, as you know, the index of the object in the emojisData array. Now let's take a closer look at the emojisData. Here I have console logged the emojisData, started a new game, and simply copy-pasted the very first item from the emojisData array and pasted it in here. We have 5 properties on this object. 2 of them, the category and the group, here, are of no use to us in this case because they are not unique to each emoji. The 3 remaining properties, the name, the HTML code, and the Unicode, are all unique to each emoji. They're not unique to a memory card, but they are unique to an emoji. Technically, we are therefore free to use any of these properties to identify matching emoji pairs, but as a service to our fellow developers, we're going to go with this one, the name property. And this is simply because the string bareface is much easier for a human being to read and understand than, for instance, this HTML code down here. Ampersand hashtag 128059 semicolon. Now that we've got this settled, I believe that you are ready for your next proper coding challenge. There are 2 parts to this challenge. First, I want you to go into the MemoryCard component. In here, you should pass the emoji.name and the index as arguments to the handleClick function down here. Second, I want you to go back into the app component and do some work on the turn card function. Here, I want you to receive the name and index as parameters, and for now, simply log them to the console to check that everything is working as expected. Please pause the scrim now, jump into the code, give this your very best shot, and I'll be back with you in just a second to show you my solution. Okay, I hope that went well. Let's start in the MemoryCard component. When we pass arguments to a function reference, just like our handle click here, there are 2 things we need to do. First, we add the brackets, and we pass in emoji.name and index, and this is pretty much what we always do when we pass arguments to functions. Second, we need to place this handle click function inside of an arrow function, like this. The reason why we need to do this is because as soon as we add these brackets, after the function name handleClick, we immediately invoke this function as soon as the MemoryCard component renders. So since we want this function to run only when one of the cards is clicked, we pass the arrow function as the function reference to the onClick event handler. And this arrow function in turn calls the handle-click function. Back here in the app component, we simply receive these parameters in the way that we always do in JavaScript functions. So we write name and index right here in the brackets. And the last thing we have to do is simply to change what is logged to the console. I chose to create this template literal here. If you did something less fancy and just logged the name and the index to the console as they are, that is completely fine. That was all that we had to do in this challenge. So let's run the code and check that everything works as we expect. We start a new game and click our first memory card. And down in the console, we get the emoji owl at index 0 was clicked. To check that our code really is bulletproof, I think we should click the other owl here as well. This one. And down in the console, we get the emoji owl at index 1 was clicked. Excellent. This means that our turncard function is successfully distinguishing between the two different owls. It also means that we are ready to move on to the next scrim. See you there. In the previous scrim, we did some work inside the MemoryCard component and here in the turncard function inside of our app component. We passed the index of the clicked memory card and the name of the emoji on this card to the function and logged those values to the console. Our task now is to take this information, the name and the index, and store them in state so that we can keep track of which cards are clicked, meaning selected by the user. I am pretty confident that this was enough of an introduction to your next coding challenge, so let's just get to it. What I want you to do is this. First, create a new variable in state called selected cards with a matching setter function and initialize this variable as an empty array. Second, go into the turncard function and set the value of selected cards to be an array containing one single item. This item should be an object with two key value pairs where the values are the function parameters. And third, log selected cards to the console to check that your code is working as expected. Please pause the scrim now, give this challenge your very best shot, and I'll be back with you in just a second to show you my solution. Okay, I hope that went well. Let's start out by creating some new values in state. We'll go up here, right below the emojisData, and say const. Then we open up the square brackets and say selected cards. And then we add the setter function, set selected cards, and we initialize this as an empty array. And that was part 1 of the challenge done. Now let's scroll down to the turncard function. I'll start out by deleting this console log since we won't need it anymore. Then we use the setter function that we just created in state, set selected cards. We open up the brackets, and what we want to set the selected cards to be is an array. So we use the square brackets. Inside of this array, we want an object. So now we use the curly brackets. And inside of this object, we want two key value pairs. There are two ways to write this object. The first one is this. We select a name for our first key, and I'll just call it name. And then we set the value of this key to be name. And then we do the same with the index. We call our key index and give it the value of index. Now, as you can see, we are repeating ourselves here because our keys and our values in both of these pairs are identical. As you might already know, we can use an object shorthand to avoid this repetition, and all we have to do is to delete the keys. So we delete this name key and just leave the value name. And we, of course, do the same for our index. Delete the key and leave the value index. This syntax will give us the exact same object as the one we had before. That was part 2 of our challenge done. The only thing we have left now is to console log the selected cards. Okay, we have a console log in place. We can delete the last bit of the challenge text and run the code to check that everything is working as expected. We start a new game and click an emoji. I'll take this one just because it's cute. Down in the console, we can now see that the value of selected cards is an array containing one single object, 2 key value pairs. The key name has the value tiger face, and the key index has the value 1. So far, so good. This was in fact the solution to the entire challenge I had for you in this scrim, but we are not quite done yet. Let's find out what will happen if we try to add more cards to the selected cards array. If I now click this pig here, for instance, down in the console, we get an array containing an object with a name property with the value of pig and an index property with the value of 4. This is pretty good because it means that our turnCard function is successfully keeping track of the cards clicked by the user and saving them in state. But when we clicked the pig, we lost our tiger face. This happened because of the way we wrote our code inside the turnCard function. Inside of our setter function, we set the value of selected cards to always be the last card that we clicked. Thereby, we are unfortunately also actively deleting any values previously stored in this array. This will happen no matter which card we click, no matter how many cards we click, we will only be able to store the very last card we clicked in the selected cards array. To solve this problem, we need to write some more code inside of our turnCard function, and that is exactly what we'll be doing in the next scrim. See you there. After all of the hard work we have done, we are now very close to having the logic for adding clicked card to the selected cards array functioning in the way that we want it to. In the previous scrim, we identified an issue with our current code, namely that selected cards can only ever contain an array with one single object in it. Before we go ahead and start fixing this problem, I want you to try to figure out if there's anything else we need to consider when we write our new code inside the turnCard function. Therefore, I have prepared this mini challenge for you. Based on the rules and mechanics of a memory game, I want you to try to define the conditions that we need to build into our turnCard function. You should make sure to consider the following aspects. 1. How many times can a card appear in the selected cards array? And by a card, I mean one and the same card. And 2, what is the maximum number of cards that we can have in the selected cards array at any given time? This mini challenge is not about writing code. I don't expect you to write any code whatsoever. I don't expect you to define the conditions in code. But I highly encourage you to write pseudocode to try with your own words in plain English to explain what it is that we have to do here. So please pause the scrim now, try to figure this out, write some pseudocode, and return back to me when you think that you've got it. Okay, hopefully you came up with some clever answers to these two questions. My answers are short and simple. Any given card can only appear in the selected cards array one time. And the maximum number of cards that we can have in the selected cards array at any given time is 2. Let's just take a quick look at our app to make it completely clear why this is the case. In any memory game, whether analog or digital, the mechanics are the exact same. The player starts the game by turning a card, this one here for instance, with a B as its value. And now their job is to find the matching B somewhere else in the game. So the first thing we want to ensure is that the player doesn't cheat and selects this B again. Turning the same card twice isn't possible in an analog memory game, but it is possible in a digital memory game if we don't prevent the user from selecting the same card twice. With that rule in place, we're now forcing the player to select another card. Let's take this rose next to the B. Now we have a B and a rose visible. They are obviously not a matching pair, so we want the player to select a new card. They then take this rabbit face here, or whatever animal that is, and as soon as they do that, we want the B and the rose to be flipped back, lying face down so that their values are no longer visible. I have prepared a challenge for you where you are to translate these conditions into code. Give me a second while I paste it in here. I want you to first check if the clicked card is already in the selected cards array and I want you to store the result of this check in a variable called selectedCardEntry. Next, I want you to update the code that adds a clicked card to selected cards. And you should make sure that the following conditions are met. Any given card can only be added once within the same round, and the length of the selected cards array should never exceed 2. Finally, I want you to log selected cards to the console to check that everything is working. I do have a hint for you as well. You can use the javascript.find method to solve step 1 of this challenge. Go ahead and pause this scrim now, jump into the code, and give this one your very best. I'll see you back here in just a second to show you my solution. Okay, hopefully that went well. Let's get to work. I'll start by commenting out this setter function. We do need it later on, but we don't want it to disturb our work here in the beginning. Now we'll use the .find method to perform this check described in step 1. So we say selected cards, .find, and inside this callback function, we want to check if the index of the clicked emoji matches an index that is already stored in one of our emoji objects in selected cards. We reference the objects in selected cards with a parameter. I'm going to call that emoji. Then we write our arrow function, and we access the index property of this emoji object and ask if it triple equals the index that we receive as a parameter. Finally, we store this check in a variable called selectedCardEntry. And that was it for step 1. Next, we need to define some conditions, and there are 2 different scenarios that we have to handle. The first scenario is where the length of the selected cards array is less than 2. Here, we want to keep any value already saved in state and simply add new values into the array. The second scenario is where the length of the array is exactly 2. Here, we don't want to keep what's already there. On the contrary, we need to get rid of that and store the clicked memory card as the new and only value in our selected cards array. Therefore, we need an if statement and we need an else if statement. In both of these cases, we want to check if the selected card entry is truthy or falsy. The .find method that we use here will return one of 2 things: an emoji object that matches the criteria we set up here, or undefined if no such object is found. So what we can do inside of our conditional blocks is this. We start with the exclamation mark, and then we say selected card entry, and thereby we say only if this value is falsy, the code should run. Then we need double ampersands to add an extra condition. And again, in both cases, we need to check the length of the selected cards array. Up here, in the if block, we want to check if the length is less than 2. And down here, in the else if block, we want to check if it is triple equal to 2. If the length is less than 2, that means that there's either 0 or 1 objects already stored in state, and we want to keep those objects there. So when we run our setter function, we need access to the previous state. The way we get access to this previous state is by using a callback function here inside of the setter function. We reference whatever value is already stored in state. I'm calling this pre-selected cards. Then we create an arrow function. And now we want to use the array spread operator to spread in this previous value. And finally, we add the clicked card in the form of an object to this array. The syntax is the exact same as the one we had before, so we say name and index. Down here in the else if block, we don't care what was previously saved in state. We simply want to clear out all previous values. And actually, we already wrote the code that does this. The setter function that we have up here does exactly this, so all we have to do is bring it back to life and put it inside the else if block. And that was it for step 2. Now finally, step 3 is simply to console log the selected cards. Now let's test this out. I'll delete this last part of the challenge, open up the console, run the code, start the game, and click some cards. Let's just click the first one here. Down in the console, we see that the value of selected cards is an array containing one object with the name snail and the index 0. Let's try to click the same snail again. Nothing happens. Great! We're successfully preventing the player from adding the same snail to the selected cards array twice. How about the other identical snail down here at a different index? Let's click this one. And that works. In the console, we now have an array with two objects, both of them with the name snail, but with two different indices. And now to the moment of truth. What happens when we click a third card? I'm going to click this tree out here. And it works. Down in the console, we now have an array with just one single object. The name is Deciduous Tree and the index 4. This is absolutely amazing because it means that all of our conditional checks here inside the turnCard function are working and applying just as we expect them to. If you manage to do all of this on your own, give yourself a huge pat on the back and take a second to just celebrate your victories. When you're ready, I'll see you in the next scrim. Now that the selection of memory cards is working, it is time for us to look into how we can find matching cards. For the human brain, this task is super simple and straightforward. If we start a new game and turn the first card here and see a tulip, and then just by chance we turn the third card and see another tulip, we immediately know by comparing these two cards that we found a matching pair. There is indeed very little risk of cognitive overload when we perform a comparison like this. We know when, what, and how to compare these two cards. Our task now is to translate this comparison that we do so easily into code. Let's start out with a mini challenge just to get you thinking about how we can approach this translation. I want you to think about this. Which tool from our React toolbox can we use to check for matches every time there are two selected cards? As you've seen before with mini challenges, I don't want you to write any code. This is a thinking and possibly a Googling challenge. All I want you to do is to come up with an answer to this question. So please pause the scrim now, think carefully about this one, and return back to me when you think that you've got it. Okay, did you figure it out? The tool we need here is the React useEffect hook. The basic syntax for the useEffect hook looks like this. We need to start out by importing it up here, where we are also importing useState. Then right here, inside our app component, right below our state values, we say useEffect, then we open up the brackets, and now we create an arrow function. And finally, we add a dependencies array. And we can open up the function here. When the dependencies array, right here, is empty, the useEffect hook will run only once when the component first loads. If we, on the other hand, add some value inside of this dependencies array, we can control when the useEffect runs. In our case, we will pass selected cards to this array. When we do that, we are now controlling that the code here will run whenever the value of selected cards changes. And as you probably remember, the value of selected cards will change whenever the user clicks a card. To prove that this is in fact working the way I just described, let's just create a console log inside this useEffect. We'll simply log the string card selected every time the value of selected cards change. You probably noticed here that as soon as I ran the code, we got this log to the console, and that is because selected cards is initially set to an empty array here. So the first time this component loads, the value of selected cards is updated, and we get card selected logged to the console. When we start a new game, we don't get any console log because the value didn't change, but as soon as we click a memory card, we get this card selected logged to the console. Now that we know what tool to use, namely the useEffect hook, and how to set up the basic syntax of this hook, it is time for your next proper coding challenge. First of all, I want you to create a new state variable called matchedCards with a corresponding setter function, and you should initialize this variable as an empty array. Second, if selected cards contain two matching cards, I want you to use the useEffect hook to add these card objects to matched cards. You should make sure to not override the previous state of matched cards. I have a hint here as well. You can use the array spread operator to solve step 2 of this challenge. And just to be completely clear, I want you to use this useEffect hook that we already set up here to write the code in step 2. I hope that you're ready for this one. Please pause the scrim, jump into the code, give this your very best shot, and I'll be back with you in just a second to walk you through my solution. Okay, hopefully that went well. Let's start out by creating some new state. Up here, just below the rest of our state variables, we'll say const, open up the square brackets, and then we say matched cards, and we create the setter function setMatchedCards. And we initialize this as an empty array. And that was step 1 of our challenge done. Inside the useEffect hook here, we need an if statement, and we'll use it to check for 2 different conditions. First of all, we need to make sure that the length of the selected cards array is exactly 2. So we say selected cards.length and ask if it triple equals 2. And this is simply because there's no point in looking for a matched pair if we have less than 2 cards in the selected cards array. The second condition that we'll add here is the match itself. On every object in the selected cards, we have 2 properties. We have a name and we have an index. And as we've seen earlier, the index is unique to each card, but the name is unique to each emoji. And that means that we can use the name property to check if the 2 cards are identical. So now we say selected cards, and we want to look at the first item in this array. So we say square brackets and 0. Now we are inside the object stored in selected cards, and we want to look at the name property on this object. So we say .name. And then we compare this to the name property of the second object in selected cards. We do this by asking if this triple equals selected cards at index1 dot name. If both of these conditions are true, we know that we've found a matching pair, and we now want to add this pair to matched cards. So we use the setter function. And since we do not want to override the previous state of matched cards, we need a callback function. I will call our parameter here prev_matchedCards, and then create the arrow function. And now we can use the array spread operator with the 3 dots here to first spread in the previous state, and second, spread in the selected cards. By using the spread operator both on the previous state and on the selected cards, we ensure that everything that ends up in here are objects. If we did not use the spread operator on selected cards, if we remove these 3 dots, we would be adding selected cards as an array, but we want objects inside of matched cards. So we put the 3 dots back in. And that was step 2 of this challenge done, so I'll delete the text. Now I realize I didn't tell you to do this, but it is always a good idea to console log to check that your code is working. So let's just log matched cards to the console. We run the code, start a new game, and let's start out by clicking something that we know doesn't match. We'll take this goat here and the camel, and in the console, we still just get an empty array logged. Now let's take the panda and then the other panda down here. And you see down in the console, we now have matched cards logged out, and it is an array containing 2 objects, the panda face and the panda face. If we add some other matching cards here, let's take the cat and the cat. Down in the console, we now see first the 2 panda faces and then the 2 cat faces. So our code is working. Our useEffect is successfully checking for matching pairs whenever we have 2 objects in the selected cards array, and adding these 2 selected cards if they are identical. If you manage to write all of this code on your own, that is simply amazing. We are now ready to move forward, so whenever you feel ready, I'll see you in the next scrim. We are very close now to completing the game logic. In fact, there is just one last thing that we need to do, and that is to determine when a game is over. At this stage in the course, I feel pretty confident that I don't actually have to say much more before I give you your next challenge, so let's just get to work. Here is what I want you to do. First, create a new state variable isGameOver with a corresponding setter function and initialize the variable as false. Second, create a new use effect that sets isGameOver to true when all memory cards have been matched and the game is over. Make sure to consider the following. What value should we use in the dependencies array, and what condition can we use to determine whether the game is over? The solution to this challenge involves using the same kind of tools that we used in the previous Scrim, which is why I have deliberately left this sort of open-ended. I want you to, on your own, use your problem-solving skills to figure out how to solve this one. So pause the Scrim now, put on your thinking cap, give this your very best shot, and then return back to me to see my solution. Okay, I hope that went well. I am sure that the first part of this challenge was easy peasy for you now. You have declared so many variables in state, so let's just get going with that. Up here we say const, open up the square brackets, and then we say isGameOver, and create the setter function, set isGameOver, and we initialize this to false. For the second part of the challenge, we need a new use effect. We'll create that right here below the first one. Here's our basic syntax with the use effect hook, the callback function, and the dependencies array. Inside this use effect, we want to flip the Boolean value of isGameOver to true as soon as the game is over. The way I decided to solve this one was with an if statement. In here, we want to check if the length of matched cards is the same as the length of the emojisData. When these two have the same length, we know that the user has successfully matched every card from the emojisData. So we say matched cards dot length and ask if it triple equals emojisData dot length. Though we do in fact need to add one more condition here. If we look closely up here at our state variables, we see that the emojisData as well as the matched cards are initialized as an empty array. And logically, that means that when this component first renders, the if statement down here will evaluate to true. The game will be over as soon as the app component renders. To make sure that the game is actually on and that we actually have emojisData rendered as memory cards to the mini browser, we need to first check if we have any emojisData at all. And we can do this by checking if the emojisData.length is true. Now we have ensured that the code inside of this if statement won't run until we have actually fetched emojisData from the API and rendered it as memory cards to the mini browser. And all we have to do now is flip the Boolean value of isGameOver to true. Lastly, we need to add some value to the dependencies array to make sure that this conditional check here is performed every time we match new cards. And we can do that by simply adding matched cards to the array. And that should be it. Now I realized that I again forgot to prompt you to console log isGameOver. I apologize for that. But we should obviously do that because otherwise we'll have no way of knowing if our code works the way we want to. So now we have a console log in place and we are ready to run our code. Down in the console, we get false because isGameOver is initialized to false. We start a game and we get false again. And now our job is to match all of these memory cards. So let's just do it one by one. We take the panda, then we match the pigs, the dog here, the bat or whatever this is, and the cow. And finally, we got true locked to the console. This happened immediately when we matched the final emoji pair here. Excellent job completing this challenge. Now that we know when a game is on and when it is over, and we know which cards are selected and matched, we are now ready to move on to a very exciting part of this course, and that is the styling of these memory cards. In the next couple of scrims, we will be working on the logic needed to get this styling right. I'll see you there. In the previous scrim, we wrapped up the basic game mechanics. And as I announced, our focus will now be to style the memory cards. I would like to remind you at this stage that I have already written all of the CSS that we need, so your job will be to write the JavaScript and React code necessary for this styling to apply. In plain English, you could say that the purpose of this JavaScript and React code that I want you to write is to let each memory card know a bit more about itself. Let's take a quick look at our memory card component to see how well each of our cards know themselves. When we create the emojil variable here, we map over the emojisData that we receive as a prop, we access the emoji, and we access the index of this emoji in the data array. And then we use the name and the index down here and pass those back to the turnCard function. So a memory card clearly knows its own name and index, but it doesn't know anything else. Back here in the app component, we do a lot of work to keep track of the selection and matching of cards. We have some state up here. We have these use effects, both of them here. And we, of course, have the turnCard function down here. All of this code contributes to this keeping track of the status of each memory card. But since this information about the selected cards and the matched cards are not passed to the cards themselves, they don't know their own status. It probably doesn't come as a surprise to you that it will be your job to change that. We do have quite a lot of work to do here, so we will be breaking it up into multiple steps and multiple scrims. The first step will be to set the stage for everything else we have to do by creating a brand new component. The component that we'll create has everything to do with this memory card component, so give me a second while I paste in a challenge here for you. Here is what I want you to do. First, you should create a new component called EmojiButton, and this component should live out here inside of the components folder. The EmojiButton component should return an HTML button element equivalent to the button in the memory card component, and that is this one here. Second, I want you to refactor our memory card component here to render this new emoji button instead of the current HTML button element. You should pass 3 props to the emoji button, and that is content, style, and handle click. The content prop should have the emoji itself as its value, meaning this code here. The style prop should have the class names as its value, this code here. And finally, the handle click prop should have the function reference as its value, this code here. Third, I want you to rename the emojil variable to cardL. And the reason why I want you to do this is that I want it to be completely clear that what we are creating in here in the memory card component is a card element, while the emoji itself is rendered in the emoji button component. Finally, I want you to go inside the app component, log selected cards to the console, run the code, and click some cards to check that your refactored code is working. So go ahead and pause the scrim now, do your best to solve this challenge, and return back to me to see my solution. Okay, hopefully that went well. Let's get to work. We'll start out by creating this new component. So out here in the sidebar, I click on the components folder, then I say new file, and I get this pop-up where I can name my component. And as you can see, we now have this EmojiButton.jsx file open. Now we write the basic component syntax. Since we know that we want to export this component, we start by saying export default, and then we create the function, and we call the function EmojiButton. And now we can open up our function body. In here, we know that we want to return an HTML button element, So we say return and create this element. So far, so good. We are not quite done yet, as you can see, but let's just go back to take a closer look at the button we had inside the memory card. On this button, we have a class name and we have this onClick. So let's get those in place in our new component. First the class name and then the onClick. In order to finish up our EmojiButton component, we actually need to move on to step 2 now to take a look at the props we should pass to this new component. We know that we want to replace this button here with the new EmojiButton component. Let's start out by importing our new component into this file so that we can use it instead of our HTML button element. Up here, we use the import keyword. And since it's a default import, we don't need any brackets here. We simply say EmojiButton. And now we import this button from the EmojiButton file. To access this file, we need to go one level up back to our components folder. So we say dot, and then we use the slash to enter the file. And finally, EmojiButton. Now we can use this button down here inside of our component. We can start out by deleting the closing button tag here. And then we say EmojiButton here. And we turn this into a closing tag with the slash. Our job was now to pass content as a prop. And as you know, the content was this part of the code. So let's move it up here as part of the props. And then we say content equals, and then this code as the value. The next prop we should pass is a style prop. So we simply have to change this class name to style. And finally, instead of having this onClick here, we should pass a prop called handleClick. Now we can go back into our EmojiButton component and receive these props. I am going to directly destructure our props object up here. So I open up the curly braces and say content, style, and handleClick. Inside of the component, we can now use the props. The class name should have the value from the prop style. The onClick should have the function reference that we pass as the prop handleClick. And finally, the content of this button should be, well, the content prop. And now we are ready to delete step 1 and 2 up here and look at step 3 and 4. Step 3 was to rename the emoji L to card L. We have an emoji L here, and we are also using it down here as the content rendered inside of the unordered list. So we'll change those to card L, like that. And finally, we need to log selected cards to the console to check that our code is actually working. Inside the app component, here at the top, right below our state variables, we'll say console log selected cards. All right, this was a huge challenge. Let's cross our fingers and hope that everything is working now. So far, so good. Nothing is broken yet. We can start a new game. And we get our memory cards rendered in the exact same way as before. And now for the moment of truth, does our turn card function still work? It seems to be working. Down in the console, we see an array containing an object with the name tiger and the index of 0. If you managed to complete this challenge on your own, give yourself a huge pat on the back. This was a super important first step, and in the next scrim, we'll keep working on the styling of our memory cards. See you there. In the previous scrim, we created this brand new EmojiButton component and rendered it right here inside the li element on our memory card. Our next task is to identify selected or matched cards here inside of the memory card component so that we can eventually add the correct conditional styling to our memory cards. In order to perform these identification checks, we have some work to do here in the memory card component as well as in the app component. I believe that you are more than ready for your next challenge, so let's jump into the app component and take a look at what it is I want you to do. The first part of this challenge is to pass selected cards and matched cards as props to MemoryCard. And remember, the selected cards and matched cards are the values that we have stored up here in state. And the MemoryCard component is the one right here. This first step should be pretty simple, so let's jump back into the MemoryCard component and look at the rest of the challenge. In here, I want you to start out by refactoring the code inside the callback function of the .map method. That is this code here. Right now, the callback function is implicitly returning the list element. I want you to change that and instead make an explicit return using the return keyword. When you're done with that, I want you to do some more work inside of the callback function. You should use selected cards that you receive as a prop to check if the card that is currently created here is selected or not, and store the result of this check in a new variable called selected card entry. And similarly, use the match card prop to check if a card is matched and store the result of that check in a variable called matched card entry. I do have a hint for you as well. If you're not quite sure how to solve step 3 and 4, then go back into the app component and take a good look at the turn card function. You will find help there. So go ahead and pause the scrim now, jump into the code, give it your very best shot, and return back to me to see my solution. Okay, I hope that went well. Let's start in the app component. All there is to do in here is simply to add some more props to the memory card. So right here, after the data prop, we can say selected cards and set the value of this to be selected cards. And the same for the second prop here, we call the prop matched cards and set its value to be matched cards. One last thing that I would like to do here is to improve the readability by formatting this code a bit better. Now each prop is written on its own line, and in my opinion, this code is a lot more readable than the one we had before. With this out of the way, we can go back into the MemoryCard component and receive these props. To do that, we simply add selected cards and matched cards up here right after the data prop. The next step is now to refactor the callback function inside of the .map method. First of all, we need some curly braces here. And of course, we need to move the closing bracket down below the list element that we're returning. And we can move the closing bracket of the map method one line up and place it here right after the closing curly brackets of the function itself. In order for this to work, we also need the return keyword. So we simply say return, and then we wrap our li element inside of brackets. Again, we need to move the closing bracket down below the li element. And finally, we have some formatting to do here. Now we have an explicit return using the return keyword, and the formatting and indentation is just as it should be. This allows us to write more code inside of the callback function. Here, inside the callback function and above the return statement, we can now create these two new variables. And as I wrote in the hint here, we actually already have a solution to how we can write this code inside our app component. Here, in the turn card function, this line of code is identical to the code we want to write inside of the MemoryCard component. So I'm just going to copy this one, go back into the MemoryCard, and paste it in here. And just because I'm lazy, I'm going to do the exact same thing one more time. And in this case, simply change selected to matched. And this should be it for this challenge. At this stage, there's still no change whatsoever to the app itself, but we want to make sure that we didn't break anything. So let's run the code and see that we don't get any errors. We can start the game, and we see our emojis rendered as before. And clicking them does not cause any action visible to us, and this is good, because this means that there are no errors screaming at us at this point. Excellent! We are now one step closer to get this conditional styling up and running, and whenever you're ready, I'll see you in the next scrim where we'll keep moving forward. As you probably remember, our goal with all the hard work that we are doing currently is for each memory card to really know everything about itself. Each card needs to know if it is selected or matched in order for us to be able to conditionally set the content and styling. So far, we have ensured that this information is available to us inside of the memory card component, but we're not yet using it. Though, as you might already have figured out by now, this is about to change, because in this scrim, we'll finally go from always revealing the emoji on all memory cards to actually turning the cards and displaying the emoji only when a card is clicked. And when I say we, I do of course mean that it is time for you to write some more code. Please give me a second while I paste in the next challenge for you. In order to solve this challenge, there is work to do in here in the memory card component as well as in the EmojiButton component. To start with, I want you to pass selected card entry and matched card entry as props to the EmojiButton. And those are, of course, these variables here that you created in the previous scrim. Inside the EmojiButton component, you should, of course, start out by receiving these variables. Next, your job is to create a brand new variable called btn content, short for button content, and then use selected card entry and matched card entry to conditionally assign a value to this button content. If a card is either matched or selected, button content should be the value of the content prop, and otherwise it should be a question mark. Finally, I want you to render button content as the content of the button. And just to be completely clear, the content of the button is this. So instead of rendering the content prop, you should render the button content variable. I do have a hint for you as well. To solve step 2, you can use a ternary operator. We are back in the memory card component where your hard work will start. Pause the scrim now, do your very best to solve this challenge and return back to me when you want to see my solution. Okay, I hope that went well. At this stage in the course, this first part of the challenge should not cause you too much of a headache. All we have to do is pass some more props. So down here, right below the handle click prop, we will simply add selected card entry and set the value of this to be selected card entry. And we do the same for the matched card entry. Sweet and simple, that was the solution to step 1 of this challenge. Let's jump into the EmojiButton component to finish this up. First of all, we need to receive these props. So we say selected cards entry and matched card entry. With these props added, this part of our code up here, where we're declaring the function and receiving props, is getting pretty hard to read. So let's just take a second to do something about the formatting. So that was a lot better. Now for step 2 here, our task is to create this new button content variable and conditionally assign it a value depending on whether the card is selected, matched, or neither. We start out by declaring the variable itself, saying const btn content. And now the way I decided to solve this one was by using a combination of a ternary operator and the logical OR operator. So I start out by saying selected card entry, and here comes the logical OR operator, and then match card entry. What this does is that it asks whether selected card entry or match card entry is truthy. And if either of these is truthy, the expression as a whole will be truthy. So this is the question we'll ask when using the ternary operator. Is the card either selected or matched? If yes, we'll assign the value of the prop content as the value of this variable button content. Then we add a colon here to be able to add an alternative value in case the card is neither selected nor matched. And the alternative value should be a question mark. Finally, we want to, of course, render this new variable as the content of our button. We do that down here. This should be it for this challenge. Let's run the code, cross our fingers, and see how this plays out. Now to the moment of truth. We start the game. And we get question marks all over the place. We are no longer revealing the value of our memory cards from the very beginning of the game. But let's hope that we still do when we click one of these. We ought to give it a try to check that it works. It does. Look at this. Now what happens when we click a third card here? The two first are turned back and showing just question marks. This is absolutely amazing. We're not quite done yet. The content is in place, but our styling is still not quite the way we want it to be. We still have a bit more work to do, but nevertheless, this is indeed a milestone in our memory game. So congratulations if you managed to complete this challenge on your own. Take a break if you need it, go for a walk, drink a cup of coffee, or just celebrate your victories. And when you feel refreshed and ready to move on, I'll see you in the next scrim. It is finally time now to finish up the conditional styling of our memory cards. In the previous scrim, we managed to conditionally set the content of each card, and in this scrim, we'll focus on conditionally setting some class names. Though before I give you your next challenge, there is one small change that I would like to make to our EmojiButton component. You see this style prop here? A few scrims ago, when we created this component, I explicitly told you to write your code this way, and I did that because I really wanted you to practice passing and receiving prompts. But now we're actually going to delete this prop entirely. Inside of the component itself, here, the EmojiButton, we need to delete the style prop since we're no longer receiving it. And then we want to change the value here on the class name. Instead of this style prop, we'll simply hard code the class names. My reasoning for making this change now is that I want to handle all styling inside of the EmojiButton component itself instead of having some of it being passed as props and other parts of it being created here in the component. With this out of the way, let's go back into the MemoryCard component where I will give you your challenge. There are 4 steps to this one, but in a way you could actually say that there are just 2 steps that you'll repeat twice with slight variations in the repetition. In here in the MemoryCard component, I want you to create a new variable called cardStyle and conditionally assign it a value depending on whether a card is selected, matched, or neither. The values that you'll be assigning to cardStyle are class names, and I have of course written out all the class names you need to use right here so that you can copy paste them. When you've done that, you should take this new cardStyle variable and add it to the existing class on the li element. The second half of this scrim's challenge is written out inside the EmojiButton component. In here, I want you to do something very similar to what you just did. Create a new variable called ButtonStyle and conditionally assign it values depending on whether it is matched, selected, or neither. And this time you should use the class names I have written out right here. And just as before, when you have this ButtonStyle variable up and running, I want you to add it down here to the existing classes set on the button. I'm aware that this challenge might be a bit tricky, so I did provide some extra help for you. As you can see, I have a hint for step 1 and 3, and I've also written out what the visual result of all your hard work should be so that you can double check that all the styling that I already wrote in the CSS file is actually applying. Go ahead and pause the scrim now, do your best to solve this one, and I'll be back with you in just a second to show you my solution. Okay, I hope that went well. Let's get to work on the memory card. The first thing we want to do in here is declare this new variable. I decided to do this using what we call chained or nested ternary operators, and therefore I can go ahead and use the card keyword when declaring my variable. If you used a let variable and if-else statements, that is completely okay. Just as with a regular ternary operator, we start by adding a condition here. And what we need to check first is if a card is matched. To do that, we can use the match card entry, and after typing out the condition, we add a question mark. After the question mark, we provide the value that we want to assign to button style in case match card entry evaluates to true. And that value is, of course, card item matched. So I copy it from up here and paste it in here. So far, this looks exactly like a regular ternary operator. What's so special about the nested ones is that now, after a colon, we add a new condition. This time, we want to check if a card is selected, so we write selected card entry, then a question mark, and paste in the correct class name. Finally, we provide an alternative value in case the card is neither selected nor matched. And that value is simply an empty string. As far as I know, the general opinion on nested or chained ternary operators is that we should be a bit careful using them. And that is simply because they can be quite hard to read. In our particular case, I think that this readability issue can be solved pretty easily by just formatting the code a bit better. Now, as you can see, we have each condition and its corresponding value on separate lines, and this is, at least to me, a lot more readable code. Now on to step 2. All we have to do is to add our new variable to the class name on the li element. And I just realized that clearly I had button style on my mind because I wrote btn instead of card here. Let's just fix that. Okay, back to the class name. What we have to do down here is, first of all, change the string to a template literal. We do that by removing the double quotes, and instead we want backticks. Though the backticks themselves aren't enough here, we also need to wrap the entire expression in curly braces. This gives us a valid template literal instead of a string, and we can now use the $sign and curly braces to add card style in here. And this was it, I believe, for step 1 and 2 of our challenge. In the EmojiButton component, our job was, as I explained, to do more or less the same thing. If you struggled solving this challenge, or if you solved it using let variables and if-else statements, I would highly encourage you to try to solve step 3 in here using the nested ternary operator syntax, simply because it's such good practice to get your hands on the keyboard writing code. So if you feel like you need it, pause the scrim now and try to finish the rest of our challenge, and I'll be back with you in just a second. Okay, let's finish this up. We create the new variable, and this time it is actually button style. We need the exact same conditions as we had inside of the memory card, so we say match card entry. And if this evaluates to true, we take the class name here that we want to add to matched cards and paste it in after the question mark. Then the colon, and the second condition, which is again selected card entry, the question mark, and the class name that we want to add to selected cards. And finally, after the colon, we want the class name for cards that are neither selected nor matched. Just as before, I'll do something about the formatting here. And all we have left to do now is to add this button style variable to the class name on the button. Again, we remove the double quotes, add backticks, wrap the whole expression in curly braces, and use $sign and curly braces to add button style. And this should be it for the entire challenge. I'm going to delete almost everything here, but leave the description of the styling, just for you to be able to reference it. Now let's run the code and see how our styling looks now. We start a new game, as we've done so many times before. And you see now we get these wonderful hover effects. The background color changes to some light yellow, we have a box shadow, and if I click a card, there is this slight animation as if the card is actually flipped or turned. Now I'm going to check the focus styling, just for the sake of completion. So I use my tab key to go one step forward. We have the exact same styling as we did on hover. I can use my enter key to turn this card. And everything seems to be working. One last thing we want to do is find a matching pair so we can check that our match card styling is also applying. I believe we had this goat here, I'm not sure, let's see. We did. Now you can see the background is grayed out, and when I hover over one of these match cards, I can see that my cursor is not allowed. I'm aware that you cannot see that on your screen, but try to do it yourself. Hover over these match cards and see what a cursor not allowed looks like. This is absolutely amazing. We are done styling our memory cards. There is one last thing that I would like to point out to you before we move on. In the challenge, I told you to be careful about the order of the conditions when we set the value on our button style and our card style variables. We have to check for match cards before we check for selected cards, and the reason is that in a situation like this one, where we have just found a matching pair, these two cards are selected and matched at the same time. So since we want them to get the match card styling as soon as they are matched, we need to check for that condition before we check if they are selected. In the next scrim, we'll look at some small but important details on our memory cards, so when you're ready for that, I will see you there. As I announced in the previous scrim, we'll now work on a couple of details in the EmojiButton component and in the turn card function. First of all, we'll improve the user experience by disabling the emoji button whenever a memory card is matched. Due to the styling that we applied in the previous scrim, match cards look as if they were disabled, but actually they are not. They have this very classic look of a disabled button with a grayed out background and a cursor that is not allowed, but in fact, these match cards are as clickable as any other card in the game. We can prove this by adding a console log in here in the turn card function. Let's run the code again, start the game, and just click till we find our first matching pair. As I'm sure you noticed, we got the word clicked locked to the console every time I clicked a memory card. And notice now that when I click a match card, this cute squirrel or whatever it is down here, we still get the word clicked locked to the console, meaning our turn card function is still running. Though this is, to be honest, not a very good user experience, and your next challenge will of course be to fix this by making the button on our matched memory cards disabled. There is just one single step to this challenge. I want you to add a disabled attribute to the button and give it a value that is truthy when a card is matched, otherwise falsy. I'm not going to give you any hints here because I believe that you can do it, but if you're struggling and need some extra help, you can always ask Google or ChatGPT. Remember, there's no shame in doing either of that. Pause the scrim, solve this challenge, and return to me to see my solution. All right, hopefully that went well. Let's fix this one together. Right here, on our button element below the onClick event handler, we'll add a disabled attribute, and we want to give it a value that evaluates to true when a card is matched, otherwise false. Luckily for us, we already have a variable available to us right here inside of the EmojiButton component that does exactly that. And that is, of course, the matched card entry. Let's run the code again to see the difference here. I'll speed up now and find our first matching pair. Well, that was an easy one. The two first cards were a match. We still got the word clicked locked to the console when we turned these cards, but look at what happens now if we click one of these. Nothing at all. The console log is not running, meaning the turn card function is not called. There is one more thing I want to show you, and actually I need to find another matching pair to be able to show you that due to the position of these two cards. Give me a second. Okay, this will do. Because we have disabled our matched cards, we have also ensured that these cards are not focusable, meaning they will be skipped when we use our keyboard to navigate through the memory cards. I'm now going to turn this card here, number 4 of our memory cards, and then use keyboard navigation to move forward. I hit my tab key once. That takes me to the card right next to it. Then I hit my tab key again, just once. And now our focus ends up down here after this match card because it is skipped by keyboard navigation. So we have now successfully pulled our match cards out of the memory game to allow the user to focus only on the cards that are actually still part of the game. Our second task in this scrim is to improve the code efficiency. Let's go back into the app component and take a look at our turn card function here one more time. As I'm sure you remember, we explicitly wrote the code here inside this function to run conditionally only if the clicked card is not already selected. This works perfectly fine, honestly, but since we really don't want anything to happen if the user clicks an already selected card, we might as well not call the function at all when they do so. Therefore, I'm going to delete those parts of the code that have to do with the selected card logic. We can delete the selected card entry variable, and inside the if-else blocks, we will of course also delete this check to see if selected card entry is a falsy value. Now, if we leave the code like this and do nothing more, our memory game will be broken because one and the same card can now be selected more than once. So it will now be your job to implement the same kind of conditional logic inside our EmojiButton component. Your challenge is to refactor the onClick event handler right here on our button element. You should use a ternary operator to set the value to null if a card is selected and otherwise handle click. You should write your code right here on the event handler itself inside of the curly brackets, but before the handle click function reference. Pause the scrim now, work on this challenge, and I'll be back with you in just a second to show you my solution. Okay, I hope that went well. Let's do this together. What we want to achieve here is to not call the turnCard function in case we click a card that is already selected. Therefore, in the ternary operator that I told you to use, the condition that we want to check for is, of course, if the card is selected, and we do that using the selected card entry variable. To ensure that handle click is not called in case selected card entry evaluates to true, we add the value null after the question mark. And if selected card entry evaluates to false, we do want to run handle click, so all we have to do now is add the colon to get the correct ternary operator syntax. And that was it. Let's run the code one more time to see how this went. We turn our first memory card, and we get the word clicked locked to the console. Now I'm going to click the same card one more time, and nothing happens. Excellent. This was exactly what we wanted. Our game logic is back on track. We simply moved the conditional logic from one place in the code to another. What we win by refactoring our code in this way is that we avoid unnecessary function calls. There is no reason at all to call a function if we already know in advance that we don't want that function to do anything in case the clicked card is already selected. It's a lot more efficient to make that function call itself conditional. All in all, by adding the disabled attribute and refactoring the event handler, we have now ensured that our turnCard function is as clean and readable as possible because all the conditional logic is handled right here inside our button component, and in my opinion, this is cleaner and more readable code. With these refactorings done, we are ready to move on to the next scrim, where we'll start looking at how we can make our memory game accessible to all users. When you're ready, I'll see you there. Accessibility is a very important aspect of front-end development. The apps and websites that we build should be accessible to any user. Some of the things that we need to consider are, for instance, can the user navigate by means of both mouse and keyboard? Do we have proper color contrast? And is all content available in a clear and humanly intelligible form, both visually and to assistive technology like screen readers? In order to ensure the accessibility of our apps, we have various tools at hand, and two of these are the aria-label and the aria-live attributes. They can be used separately or in combination, and when used in combination, what they do is that they ensure accessibility by adding humanly intelligible information to otherwise inaccessible elements and determine when screen readers should read aloud this information. We will now take a closer look at them one by one and see how they can be useful to us in our memory game. First, we'll talk about the aria-label attribute. In the MDN web docs, the role and function of the aria-label attribute is described like this. In cases where an interactive element has no accessible name or the accessible name is not accurate, the aria-label attribute can be used to define a string that labels the interactive element on which it is set. You can click the link right here if you want to go to the MDN web docs and read more on your own. So when should we use aria labels? The short answer is when we have no other option. Just to give you a rather contrived example, we should not create apps that uses icons instead of clear and descriptive text all over the place on every single button, every single link, and then afterwards add aria labels to fix the accessibility issues. That is not the purpose of the aria label. On the contrary, the purpose of the aria label is to provide additional information to assistive technology about the content of some element when there is basically no way of having this information visibly available in the app. And how do we use that then? Well, I have come up with an example here to illustrate. As you know, in our memory game, the visual or visible content of our buttons that are rendered on each memory card is an emoji, just like the cute little monkey face here. As you also know, these emojis are actually HTML entities that we then decode when we render them to the screen. This means that the default accessible name on each and every one of our buttons is the HTML entity. So if our user, for instance, rely on a screen reader to navigate through our app and understand what is on each button, all they'll get is the HTML entity, and that really isn't human-friendly. To fix this issue, we can add aria labels to our buttons describing the rendered emoji. Our little monkey friend here has a name in the world of emojis, and we can take this name, monkey face, and set it as the value of the aria label. In this way, we ensure that when our user encounter a monkey face, they get the string monkey face read aloud to them. Next up is the aria-live attribute. This attribute controls when a screen reader should read aloud the content or aria label set on an element. It takes one of the following three values: off, which is the default, polite, and assertive. The difference between polite and assertive has to do with, well, politeness. If we set the aria-live attribute to assertive, this means that the screen reader will interrupt any other activity or action that is going on in the app to read aloud the aria label that we set on that particular element. Often that is not a very good idea. It can be useful in some situations, but it's much more common to use polite because polite waits politely for the right timing, and when there's nothing else important going on, the screen reader enters the scene with this new information politely. And when should we use this aria-live attribute then? The attribute is used to make dynamic content changes available to assistive technologies. To understand exactly how this works and how we should write our code, I've come up with another example for you. Here we have an HTML button element that is rendering a question mark. You probably recognize this from our memory game, where we also have an HTML button element that renders a question mark. On this button, there is an aria label with the text "card upside down." This information is needed because the question mark itself is not really what I would call humanly readable and intelligible information about the button. What does question mark on a button mean? When you can just use your eyes and your vision to look through a memory game, it's quite easy to understand this question mark, but when you can't, it doesn't really make sense. So we add the aria label "card upside down" to provide information about the status of this memory card. Below the aria label, there is an aria-live attribute set to polite. As you very well know, when this button is clicked in our memory game, the content of it changes. Suddenly, we have a button rendering an HTML entity instead. The aria label has to change to match this HTML entity, and the aria-live is still polite. We're not going to touch that. The combination of the aria label and the aria-live ensures two things here. As soon as the user focuses one of our buttons, the aria label is read aloud. When the user then turns that memory card, the new aria label is read aloud because the aria-live attribute is set to polite and not off, which is the default. Now let's go into the code editor and take a look at these accessibility tools in action. I have created this very basic and very boring app that mimics the functionality of our memory game. In this app, we have just one single button, and when we click it, the content on it changes from a question mark to a monkey face. And if we click it again, it changes back to a question mark. The button is rendered right here inside the return statement of our app component. On this button, we dynamically set the content using the content property from the state variable btn value. The state variable is declared up here at the top of the component. It is initialized as an object with the content set to a question mark and the aria-label set to the string card upside down. Back on the button, we also have an onClick event handler that calls the function setButtonContent. Inside of this function, we use the setter function from state to toggle both the button content and the aria-label back and forth between question mark and monkey face. Right now, this button lags when it comes to accessibility because the default accessible name is the content on the button, so it's either a question mark or it's an HTML entity. To fix this, we need to add both an aria-live and an aria-label attribute to the button. Aria-live is the easiest one of these two. We simply set the value to polite. On the aria-label, we want to use the aria property on our btn value object that we save in state. So we type out btn value.aria. Together, these two aria attributes ensure that whenever the value of the button changes, the updated aria label will be presented to users of assistive technologies. When we set the value of the aria label attribute on an element, there's one last thing that's really important, and that is to always finish off the string with a period. The period at the end is a signal to the screen reader that it should pause for a little while before moving on and reading aloud whatever is next in line. To add this period, we have to turn the value on our aria label into a template literal, and we do that by adding backticks and an extra set of curly braces around these backticks. Now we have a valid template literal, so we can add a $sign in front of the variable and a dot at the end. In order to properly test that our code is working, we would need to have a screen reader installed, turn that one on, and click our button to hear what it reads aloud. And if you happen to actually have a screen reader installed, I highly encourage you to go ahead and do that. Though if you don't, that's completely fine, and what you could do instead is to open up your browser developer tools and inspect the button element. On this element, you should see that the aria label changes whenever you click the button and the content of it changes. In the next scrim, we will return to our memory game and use everything we've just learned to make our memory cards accessible. So when you're ready for that, I will see you there. In this scrim, we'll take what we just learned about the aria-label and aria-live attributes and apply it to our memory game. Though before we get going, there is one small change that I want to make to our EmojiButton component. Right now, we are passing this content prop, and we've set its value to be the decoded HTML entity, which we then use inside EmojiButton to render the emoji. Instead of doing it like this, decoding the HTML entity here, we're now going to pass down the entire emoji object. I'm going to leave the content prop here for a little while just for us to reference it, and then right below it, create a new prop called emoji, and then pass in the emoji object as its value. In the EmojiButton component, we'll receive this emoji prop, and then we'll use it right here instead of the content prop when we create the conditional values of the button content. Just as we decoded the HTML entity before inside the MemoryCard, we'll now do this decoding inside the EmojiButton. So we can actually just copy this line of code, go back to the EmojiButton component, and use that instead of the content prop. And since we're now using the decode entity method here, we also need to import that into our component. Again, we can do some copy pasting. We simply take the import that we've written up here cut it out, go back to the emoji button, and paste it in here. And now we should be able to delete the content prop entirely here where we are receiving it, and in the memory card where we are passing it down. Let's just run our code to make sure we didn't break anything. Here we have our memory cards lying face down, and when I click one of these, we still see the emoji rendered. Great, that means that everything is still working the exact same way as it was before. The reason why we're doing this refactoring is because we need access to the entire emoji object inside of the EmojiButton component to make those buttons accessible. As you know, we can use the aria-label to make information about an interactive element available to assistive technologies. But exactly what information should that be in our case? Before I answer that question, I want you to think about it on your own, so I have prepared a mini challenge for you. You don't have to write any new code now. What I want you to do is simply to think and come up with an answer to this question: what information about each memory card does the user need to be able to play our game? Pause the scrim now and give this some thought. Okay, did you figure it out? Let's look at the game together. Right now, we have 10 cards rendered. One of them is turned and showing a turkey, and the rest of them are lying face down. By just looking at this, I can see that there are 10 cards. I can see that it is the very first card that is turned, and I can see what value is on that card. If I turn another card, I'm just going to take a random one down here, for instance. I can now see that that shows a koala, and I know where this card is positioned relatively to the rest of the cards and relatively to the turkey. To be able to find matching pairs in here, I need to remember where I found this koala and where I found the turkey. So that means that I need information about the value and the position of each card. Now that we've got that cleared up, it is time for your next proper coding challenge. There are 4 steps to this challenge. The first one is written out in the memory card component. This one is pretty simple. You should pass the index as a prop to the emoji button. Then back in the emoji button component, I want you to create a new variable called button area and conditionally assign it a value depending on whether the card is matched, selected, or neither. I have written out the values that you should use here, but as you can see, on matched and selected cards, I'm simply telling you that you should show the name of the emoji, but I'm not telling you how you should do that. When you've created this button area variable, I want you to set an aria-label on the button. The value you give it should inform about the position of the card and also contain the button area. In case this feels a bit confusing, I have given you an example right here of what it is I want you to do. For instance, an aria-label could say position 1, monkey face, period, not matched yet, period. Finally, I want you to set an aria-live attribute on the button and give it the value polite. I do also have a hint for you. You can use the index prop that you're now receiving to determine the card's position, but do remember that humans start counting from 1, not 0. Go ahead and pause the scrim now, do your very best to solve this challenge, and return back to me to see my solution. Okay, hopefully you managed to solve this challenge. Let's get to work in the memory card component. All we have to do here is to pass the index as a prop to EmojiButton. We call the prop index and give it the value index. Back in the EmojiButton component, we receive this index prop, and then we start working on step 2, where we are to create a new variable called button area. I'm going to stick to my nested ternary operators, so I can say const button area, and then make my first check to see if the card is matched. If so, I want the value to be the name of the emoji and the word matched. To be able to combine these two, I'll create a template literal. Then I add in the name of the emoji using $ curly braces. And as we know, on each emoji object, we have a name property. Then I put a period here and write the word matched. And of course, it's super important to remember the period after the last word in the string. I happen to know that an emoji name can contain HTML entities because things like apostrophes are represented with HTML entities in the API that we're using. So to make sure that our emoji name is actually humanly readable, we have to decode that one as well. So I wrap it in brackets and use the decode entity method. If match card entry evaluates to false, I want to check if the card is selected. And if so, I'm going to do pretty much the same as I just did up here. So I'm going to cheat a bit now, copy this bit of the code, and paste it in down here. And instead of matched, I'll simply write not matched yet. And finally, if the card is neither matched nor selected, the value that we want to set on button area is card upside down. In step 3, we are to set an aria label on the button. We can do that right here below the disabled attribute. And from the example that I gave you, we know that we want to write out the word position, and we also want to use some variables here, so we need a template literal again. Therefore, we start with backticks, then we can type out position, and use the index here. As you know, the index of the very first item in an array is 0, not 1, and humans tend to start counting from 1 and not from 0 when they see 10 memory cards rendered to the screen. So we have to say index plus 1 to make sure that the first card actually gets position number 1. Now we add the colon, and we add in the button area. Finally, we create an aria-live attribute and give it the value polite, like this. This should be it for this entire challenge. If we really want to make sure that this is working, we have to use a screen reader, but since I already double-checked this a ton of times, I think it's good enough if we just check that we get no errors, and then you'll just have to trust me that this will work the way we intend it to if we turn on a screen reader and play a memory game. But let's at least run the code to check that nothing is broken. We start the game, we click some cards, and we get no errors screaming in our faces, so everything seems to be good. Awesome! We just made a huge improvement to the accessibility of our memory game, and you should be very proud of yourself for working on this challenge, solving it the best you could, and now knowing a bit more about accessibility. When you're ready to move on, I'll see you in the next scrim. In order to avoid potential confusion regarding the state of our memory game, I have decided to rename one of our state variables, namely this one here, is GameOver. The core functionality of this state variable is to keep track of when all memory cards have been matched, and after some consideration, I decided that it would be better if the name reflected this functionality. So now I'm going to rename it to Are All Cards Matched? I don't want to go into too much detail about why I think this change is important, simply because the potential confusion that I was talking about lies in the future. But what I can say is this. I realized that having both an isGameOn and isGameOver state variable was not really intuitive or logical. And since we do need both of them, the obvious solution was to improve the naming of one of them. It is definitely not one of my proudest moments to interrupt my own course with such a change, but as you know, coding is a never-ending work in progress. Very often we learn as we go, and the best thing we can do is to incorporate changes and improvements to our code as quickly and openly as possible, so that our fellow devs can easily follow along and understand our work. So with this out of the way, we are ready to move forward again. In this scrim, we are going to create a brand new component called AssistiveTechInfo. We need this component to further improve the accessibility of our app. Making the memory cards themselves accessible, as we did previously, is by far the most important part of the accessibility work we have to do in this project, but it's not the only part. So what is this new component going to do? Well, it's going to provide additional information to users of assistive technologies informing about the game status. To illustrate what I'm talking about here, I'm just quickly going to start a new game and find some matching pairs. When I play this game, I can see how many cards are matched and how many I have left to match. In this case, for instance, we have at this stage 2 matched pairs and 6 cards left to match. For sure, I can live without this information. This is not what will make or break my game flow, but I must say I'm really glad to know this because it sort of gives me an overview of where I'm at in the game. Users of assistive technologies don't have immediate access to this information unless they tap through all the memory cards. And still, even if they do so, they will have to do some math afterwards because, as you very well know, the match cards are disabled and therefore skipped when we navigate with our keyboard. Because we are smart and attentive developers, we know that this is not a great user experience, which is why we'll of course make sure to give all users access to all relevant information about the game's status. So now that you know why we need this new AssistiveTechInfo component, it is time for you to actually create it. Here is what I want you to do in this challenge. First, you should create a new component inside of the components folder and call it AssistiveTechInfo. The component should take 2 props, emojisData, and matched cards, and it should return a section element containing 1 H2 and 2 P elements. The content of these elements, the H2 and the Ps, is written out right here as part of step 1. In step 2, I want you to render this new component between the form and the MemoryCard. That is down here in this space I just created for you. And you should render it conditionally when isGameOn is true and are all cards matched is false. And do, of course, remember to pass down the props. In step 3, I want you to play a memory game to check that everything is working, both the dynamically updating content and the conditional rendering of the component. And when you're sure that everything is working, step 4 is to add the class SR only to the section element inside of the AssistiveTechInfo component to hide it from the window. For now, please don't worry about setting any area attributes on the new component. We'll be working on this in future scrims. Pause the scrim now, work on this challenge, and return to me to see my solution. All right, hopefully that went well. Let's get to work. We'll start by creating the new component inside of the components folder. We know that we want to export a component from this file, so we'll start by saying export default. Then we'll declare the function and call it AssistiveTechInfo. In here, we want to return a section element, so we'll start with a return keyword, open up a set of brackets, and then create a section element. Inside of the section, we want an H2 and 2 P elements. Before we can finish our component here, we need access to the emojisData and the match cards array that we have saved in state. So we know we want to receive those as props. I chose to, again, destructure my props object directly here inside of the brackets. To get the number of match pairs and display it here on the first P tag, we can take the match cards array, which contain all of our match cards, and then divide it by 2 because we want to show the number of matched pairs. To do that, we add curly braces, and then we say match cards dot length and divide it by 2. Similarly, when we want to know how many cards we have left to match, we do some math involving both the emojisData and the match cards. We know that we have a total of 10 memory cards because we have 10 emojis in our emojisData. And if we subtract the match cards from the emojisData, we get the number of memory cards that are not yet matched. So again, we open up the curly braces, and this time we say emojisData.length minus matchcards.length. Let's go back into our app.jsx and import this new component. We do that up here, right below our other imports. So we say import AssistiveTechInfo from the components folder and the AssistiveTechInfo file. Oh, and I see I made a typo here. AssistiveTechInfo. Now that we've imported it, we can render it right here. We know that we want to render it when the game is on. and when the boolean are all cards matched is false. So now after this second logical AND operator, we simply type out our component name. Our component is receiving the props emojisData and matched cards, so let's make sure that we actually pass those props. And finally, just to make sure that this is still readable, we'll do something about the formatting. Okay, I think that was a lot better. That was, I believe, step 1 and 2 of our challenge. Now step 3 is to play the game and check that everything is working. Now when we start a new game, we get this game status section rendered above our memory cards. Right now, our game status is that the number of match pairs is 0 and the number of cards left to match is 10. Let's find our first matching pair to check if the values update correctly. Here we had a matching pair, and now our game status is correctly showing that the number of match pairs is 1 and number of cards left to match is 8. To make sure that this section disappears again when all the cards are matched, I'm just quickly gonna go through this game and match all of the pairs. Okay, this is the moment of truth. I have 1 card left to turn. When I turn this card, the game status section should be hidden again. And it is. Excellent. That means that our conditional rendering is working and our dynamically updating content inside of the section is working as well. The fourth and final step of this challenge was to add an SR-only class to the section element in the AssistiveTechInfo component. So right here on the section, we say class name and SR-only. SR is short for screen reader. The whole point is here that we don't need to display this information visually on the screen, but we need to keep it accessible to screen readers, which is exactly what the CSS I have written on this SR-only class is doing. And you know what? I think that we should actually take a quick look at the CSS together. Here we have it, the SR-only class. And as you can see, there is a lot more to this than just setting the display to none or set visibility to hidden. If you want to hide something, like really hide it so that nobody will ever find it, then go ahead and use one of those, display none or visibility hidden. But if you want to hide something only visually and keep it accessible to assistive technologies, this is one of the better ways to do that. I did not come up with this solution on my own. On the contrary, I found it here on the source that I am linking to. I highly encourage you to check it out on your own, or at the very least, keep in mind that hiding things from the screen should always involve considerations when it comes to the accessibility of what it is you're hiding. With that said, we are ready to move forward, and in the next scrim, we'll do a bit more work to make sure that this component really is accessible in the way that we want it to be. See you there. In this scrim, we'll take a look at another one of our accessibility tools, namely the aria-atomic attribute. In the MDN web docs about this attribute, which I have, by the way, linked to right here, it is described like this. When the content of a live region changes, the DOM is traversed from the changed element through its ancestors to find the first element with aria-atomic set. This determines the content that the user should be presented with. If no ancestor has explicitly set aria-atomic, only the node or nodes of live region content that have been updated are read. This is quite a thorough and accurate description, but what exactly does all of this mean? Well, let's try to break it down into something that is hopefully easier to understand. First of all, why do we need this aria-atomic attribute? When we're dealing with aria-live regions, the aria-live attribute controls if or when assistive technology should present dynamically changed content to the user. By default, only the changed content is presented, even when aria-live is set to polite or assertive. In this context, we could say, a bit simplified maybe, that an aria-live region is some content that is grouped together. Some of this content changes dynamically, for instance, through user interaction, and some of it does not. And if we, in this situation, rely only on the aria-live attribute, as we talked about in a previous scrim, the static content will be omitted. So if it's important that the static content is read aloud together with the dynamically changing content, we have to find a way to let assistive technology know that this entire region should always be read aloud with all of its content. And that is exactly where the aria-atomic attribute comes into play. With this attribute, we can take control of this default behavior where only the changed content is presented, and instead decide if unchanged or entirely static content should be read aloud too. And how do we use aria-atomic then? We set the attribute on a live region, for instance a div or a section, that is containing dynamically changing content. The attribute takes either true or false as its value. If we set the value to true, the entire live region is treated as a single unit, and all content, whether static or dynamic, is read aloud whenever any part of it is changing. If, on the other hand, we set the value to false, the region is not treated as a unit, and only changed content is read aloud. One more important thing to know is that if we don't set an aria-atomic attribute at all, the outcome will basically be the same as if we set it to false, only the changed content will be read aloud. I have, of course, prepared an example that illustrates the use of the aria-atomic attribute, but before we get to that, let's just quickly recap the aria-live attribute. The buttons that you see here are not new to you. I copy-pasted them from the slide about aria-live, and what they illustrate is one and the same button with changing content and a changing aria label. When the button first renders, we see a question mark. That is the button to the left here. And when we click it, the content changes to an HTML entity and the aria label changes from card upside down to monkey face. Since we have set the aria-live attribute to polite here, the changed aria label will be read aloud whenever this button is clicked and the content and aria label is changing. If we take this very same button and place it inside of a div together with some static content, in this case an h2, rendering the string static heading, we will have to consider which parts of this content we want the assistive technology to present to our users. On the div to the left here, there is no aria-atomic attribute, meaning that whenever we click this question mark button and the content and aria label of the button is changing, only the aria label set on the button will be read aloud. The static heading will be skipped. If we, on the other hand, set aria-atomic to true, all content inside of this div will be treated as a single unit and everything will be read aloud. I have once again created a very simple and super boring app to illustrate how this works. Our question mark button here that has the same effect as you've seen before, we click it and the content changes to a monkey face, we click it again and it turns back to a question mark. This button is placed inside of a container, a div, that I have styled here with a border so that you can see exactly what is part of this div. The div you can see is rendered right here. And apart from that, the rest of the code is more or less identical to what you saw in the Scrimba about the aria-label and aria-live attributes. Our h2 here, the static container heading, is absolutely crucial. Without this heading, our user will be completely lost when it comes to understanding what is going on with the button inside of the div, and therefore we must ensure that assistive technologies read aloud our static container heading together with the changing values on the button. To do that, we go up here on the div and we set the aria-live to polite, and we set the aria-atomic to true. Now we have ensured that everything inside the div is treated as a single unit and that all content is read aloud whenever parts of it is changing. With this new aria-atomic attribute under the belt, we are ready to return to our memory game and work on the accessibility of our new AssistiveTechInfo component. See you there. Now that you know how the presentation of live region content works and what tools we can use to control it, let's just get straight to work here in the AssistiveTechInfo component. First, I have a mini challenge for you. I want you to try to come up with an answer to the following question. which parts of the content in this component will be read aloud when there are dynamic content changes and which will not. Pause the scrim now, give this some thought, and return to me to hear my answer to this one. Okay, do you have an answer ready for me? No matter what, I have an answer ready for you, and the answer is nothing. Nothing at all will be read aloud. This was in fact a bit of a trick question, and that was of course deliberate, since no parts whatsoever of the content here will be read aloud when there are dynamic content updates. And that is simply because we didn't do anything to prompt screen readers to do that. So if we leave the code as it is now, all of our hard work with this component will be in vain, because the information that we are trying to convey to the user will never be presented to them by assistive technologies. Luckily, you know how to fix this, so without further ado, I'm going to give you your next proper coding challenge. In this challenge, I want you to fix the issue that we just discussed. You should turn the sectioned element and its children into a single unit and prompt assistive technology to present all content of this live region to the user whenever parts of it change. Pause the scrim now and work on this challenge, and I'll be back with you in just a second to show you my solution. All right, I hope that went well. All we have to do here is to go down to a section element and add an aria-live attribute with the value polite and an aria-atomic attribute with the value true. With these two attributes added, the entire section with all of its content will be read aloud by screen readers whenever any value rendered inside of it changes. Now, you might think that this challenge was so basic and simple that it was a bit silly of me to even make it a challenge. But as I'm sure you heard before, getting your hands on the keyboard and writing code is by far the best way to actually learn to code. You learn by thinking and by doing, not by watching me do it. Besides, coding doesn't always have to be painfully hard work. Every now and then, it's okay to just implement some quick fixes and have a good time. When you're ready to push forward with our memory game, I'll see you in the next scrim. In this scrim, we are once again going to create a brand new component. The component we'll create this time is to pop up above the memory cards when the user has matched all memory cards into pairs. And you know what? I don't think that I actually need to say anything more to prepare you for your next challenge, so let's just get to it. Here's what I want you to do. Go into the Components folder out here on the sidebar and create a new component called GameOver. This component should return a div containing a p element. Right here, as part of step 1, I have written out what content and styling you should set on the div and the p element. In step 2, I want you to render this new GameOver component right here, and you should render it conditionally when the state variable are all cards matched is true. Finally, I want you to play a memory game to check that the conditional rendering of this component is working. Pause the scrim now, work on this challenge, and return to me to see my solution. Okay, hopefully that went well. Let's do this together. First of all, we'll create the new component out here in the Components folder. And then in here, we write the basic syntax for our GameOver component. We'll make a default export here, and inside of the component, we'll start with the return keyword. And what we want to return is a div element. And inside of this, we want a p element. Now to get the styling and content in place, I'm just going to speed up and do some copy pasting. There we go, the styling and content is in place. Let's go back to the app component to finish the challenge. We can delete step 1 here. And in step 2, we want to render this new component. In order to render it, we do of course have to import it first. We'll do that up here together with the rest of our imports. So we say import GameOver from, and it lives inside of our components folder in the file GameOver. Now we can scroll back down to the return statement and render the component here between the brackets. The condition for rendering this one is that are all cards matched has to be true. So we say are all cards matched, and then use the double ampersand, and now we render an instance of GameOver. The only thing we have left to do now is to play a game and check that the conditional rendering is working. Now let's run the code, start a new game, and I am going to speed through this one. Okay, here we are with one card left to turn. This is the moment of truth. We turn the last card, and look at that. Our new GameOver component is appearing just as it should, conditionally when all of the cards are matched. So far, so good. Though we are not quite done with this component yet, because we want to also add a button to it, allowing the user to play a new game if they want to. To fix this, we'll need to write some more code inside the GameOver component, and we'll also need to create a new function here in the app component. When you're ready to move on, I'll see you in the next scrim. As I announced in the previous scrim, we want to add a button to this new GameOver component that we are rendering here. This button should reset the game and bring the user back to the form that we're rendering when our app first loads. I am not going to say more right now about how we can reset the game, because I want you to try and figure that out on your own. So what are we waiting for? Let's get going with your next coding challenge. In step 1, I want you to create a new function called resetGame. As the name indicates, the function should reset the game, but it should not modify emojisData or interact with the Emoji Hub API in any way. In step 2, you should pass this new function to the GameOver component as the value of a prop called handleClick. When you've done that, I want you to go into the GameOver component, and here you should render an instance of the regular button component right below the P element. That is right here, where I have just created a space for you. And remember, the regular button is a component that lives out here in the components folder. The regular button should receive handleClick as a prop, and remember, you just pass down that prop from the app component to the GameOver component, so now you're going to pass it one level further to the regular button. And the content of this button should be play again. Finally, in step 4, I want you to play a game, and when you've finished, you should click this new play again button to check that everything is working. Clicking this button should make the previous game disappear and instead make the form component render again. If you're not quite sure what to do with this regular button component that I want you to use, then take a good look at the hint I've written out for you here as well. All right, pause the scrim now, give this your very best shot, and return back to me to see my solution. So I hope you managed to solve the challenge. Let's go back into the app component and get started together. Right here, below the turnCard function, we're going to declare the new function called resetGame. In order to perform this resetting, there are some state variables that we need to set back to their initial state. We know that we are not supposed to touch this one, the emojisData. But apart from the emojisData, we actually have to set all other state variables back to their initial state. IsGameOn has to be set back to false. Both the selected cards and the match cards arrays have to be cleared, set back to empty arrays. And finally, are all cards matched should be set to false. I'm just quickly gonna type out these setter functions to get our resetGame function up and running. And that was it for our resetGame function. Running this code here will hide the old memory game. It will set all state variables related to the game mechanics back to their initial state, and it will bring the form back to the mini browser. In step 2, all we have to do is to pass down this new resetGame function as a prop called handleClick to our GameOver component. So we say handleClick and add resetGame as the value. That was it for step 1 and 2. Now let's go into the GameOver component to finish the job. The first thing we should do in here is, of course, to receive the prop that we just passed. I didn't explicitly write this in the challenge, and that is just because I'm teasing you a bit. I wanted to make sure that you are still awake, so by omitting this information, I forced you to remember it all on your own. The next step is to render an instance of the regular button component. To be able to do that, we have to, of course, import it first. So up here at the top of the file, we say import regular button from the file regular button that lives here in the same components folder as our GameOver component. To access this file, we start out with a dot here to go one level up to the folder, then we use the slash to enter the file, and then we say regular button. Inside of the div that we are returning, we can now render an instance of this button. You might have been tempted to render the button like this, writing the component name only once and with the closing tag right after the name here. And if you did, you ran into problems, right? Hopefully my hint was helpful to you in that situation. Let's take a quick look together at these two components that I was hinting about. First, the regular button itself here. It receives two props, children and handle click. The handle click is what is being passed here to the onClick event handler, and the children is the content that is rendered on this button. Now, to understand how we use instances of this component, let's take a look at the form component as well. Here, as you can see, we are rendering an instance of the regular button component using both an opening regular button tag and a closing regular button tag. And in between those, we have this string here, start game, which is the content that is rendered on our form button. On the regular button opening tag here, we have just one prop called handle click. So by looking at how the regular button component is used here inside the form, we now know that the children prop received by the regular button component is the actual children rendered here between the opening and closing tags. Therefore, back in our GameOver component, we have to use the exact same syntax. Instead of this closing tag here at the end, we need to have both an opening and a closing tag with the component name regular button. The children prop that we want to pass is the string play again, and the handle click prop is passed right here on the opening tag, and we simply use handle click as both the name and the value of this prop. That was step 3 done, so all we have left to do now is to play a game and check that it is working. Once again, I will just speed up and match these 10 cards into 5 pairs. So now there is one card left to turn. I click it. Our GameOver component turns up above the memory cards. We have our play again button here, and when we click it, the memory cards disappear, and we're back to where we started, seeing only the form component. To make sure that our code really is bulletproof, let's just start a new game to check that we didn't mess anything up. Everything seems to be working still exactly as it did before. Amazing! The reset game function that we are calling from this GameOver component is working perfectly, just as we want it to. We do still have a bit of work to do on this GameOver component because right now it is unfortunately lacking when it comes to accessibility. And as you know by now, smart and attentive developers like you and me will not accept that. We want all users to have a marvelous experience when they play our memory game. So when you're ready to tackle your next accessibility challenge, I'll see you in the next Scrim. The accessibility issue that we are facing here with our GameOver component is that users of assistive technologies are not informed about the sudden appearance of this new component. When I play the memory game and I turn the very last card here, then because I can see what's on the screen, there is an obvious change happening and my attention is drawn to the new GameOver component. But when you can't see what's on the screen, you are quite frankly lost here. You don't immediately know that the game is over, nor that there is a new button you can now click to play the game again. In fact, you'll have to use assistive technologies to navigate through the entire app until you hopefully and totally by chance find the GameOver component. Previously, when we've fixed accessibility issues, we have used various aria attributes to prompt screen readers to read aloud parts of our app. But this time, that approach won't work. You see, all the content here on our component, both on the P element and on the button element, is static. So telling assistive technologies to look out for changing content just won't have any effect. Therefore, we need a different approach here. In the next scrim, we'll look into how we can use JavaScript's .focus method to ensure the accessibility of this component. See you there. In this scrim, we'll look at how we can add focus to a new DOM element and thereby fix accessibility issues like the one we identified in the previous scrim. Unfortunately, this is quite a bit more complex than it might sound. In the previous scrim, I announced that we can use JavaScript's .focus method to ensure the accessibility of our GameOver component, and that really is true. Though the thing is, we also have to use two different React hooks and a global attribute to actually make this work. But let's not dwell anymore on the scary complexity of the task at hand, and instead just move forward and try to demystify it. The issue that we are facing is this. When a new element or component is rendered to the DOM, it is not immediately presented to users of assistive technologies. The solution to this issue is to programmatically add focus to this new DOM node and thereby prompt screen readers to read its content aloud as soon as it renders. To achieve this immediate presentation by screen readers of a new DOM node, we need to use a cocktail of tools. We need the React useRef hook, the React useEffect hook, we need the JavaScript.focus method, and the tab-index global attribute. As you can see, each of these tools are styled here on the slide with a different text color and an underline, and that is because all of them are links. You can click them to get directly to the relevant documentation if you want to read more on your own. Now, let's talk about these one by one. What do they do? Why do we need them? First, the React useRef hook. In a React component, we can use the useRef hook to create what is called a ref. This ref can then be passed to a ref attribute on a JSX element. And in that way, we sort of create a reference to that specific element. This ref that we are creating is actually an object, and it has one single property called current. That means that in order to work with this ref, to manipulate the value of it, or to use inbuilt browser APIs on it, we need to always access this current property. The second tool here is the React useEffect hook. We use the useEffect hook to run some code when the component first renders. The code that will run inside of this useEffect hook is the JavaScript.focus method. We will chain this focus method on the ref.current that we're creating in the first step. Finally, we'll add a tab index attribute to the same JSX element where we're also adding the ref attribute. This ensures that the element is actually focusable. By default, all interactive HTML or JSX elements, such as buttons or links or input fields or text areas, are focusable. That means that we get keyboard navigation and accessibility advantages right out of the box when we use interactive elements. Non-interactive elements, on the other hand, are not focusable. Those are elements such as sections, divs, headings, p tags, and so on. As soon as we set a valid value on the tab index attribute, the element becomes focusable. In our specific case, we'll set the value to be -1 because this makes the focusable element non-tappable. The term tappable refers to that a user can use their tab key to reach this element. When a focusable element is non-tappable, that means that you cannot use your tab key to navigate your way to this element, but you can still programmatically add focus to it using the focus method. This is quite a mouthful, I know that. So to give you a fair chance to digest all of this and actually understand how it works, I have, of course, created another one of my pretty simple and very boring apps. I am sure that this setup looks familiar to you, but there's more than meets the eye. Take a look at what happens when I click the button. Wow, not only did the question mark turn into a monkey face on the clicked button, we also have these two cards up here above the monkey face button. The card to the left reads, "Focus, you found the monkey," while the card to the right reads, "You found the monkey secretly." Right now, there is actually no difference whatsoever between these two cards apart from the text content. But we are going to change that and add focus to the card to the left when the two cards render so that you can see the difference between a focused and a non-focused card. In our index.jsx file, we have an app component and a card component. The app component renders this monkey face / question mark button. And as you've seen before, clicking this button calls the handle click function, which then updates both the content and the aria-label of the button. So far so good. This is all familiar code to you. What also happens when this function runs is that the isMonkeyFound state variable, which is declared up here, is toggled right here using the setter function. isMonkeyFound is initialized to false, which makes sense because when our app first renders, the content on the button is a question mark and there really is no monkey found there. Flipping this boolean value from false to true triggers the rendering of the card component. The cards are rendered only when isMonkeyFound is true. As you can see, the card component is right now super basic. It simply returns a section containing two divs, each rendering a p tag. Now our job is to add focus to this div here when the card component renders. As you now know, we need 4 different tools to make this happen. We need the useRef hook, we need the useEffect hook, we need the .focus method, and we need the tab index attribute. Let's start by importing useRef and useEffect from React. We do that up here right after the import of useState. And now the hooks are available for us to use inside of our component. Now the first thing we'll do is that we'll create a ref using the useRef hook. We do that with a const, and I'm going to call this ref cardRef. We set this ref equal to useRef, and we'll set the initial value here to be null. Now that we have a cardRef declared, we can pass that as the value of a ref attribute on the div that we want to focus. So right here on the first of these two divs, we say ref, and then between the curly braces here, we pass in the cardRef. This gives us a reference to this div that we can now work with inside of a useEffect hook. We want to access the cardRef, and this cardRef is an object with one property called current. On this cardRef.current, we can now chain the .focus method. This code ensures that as soon as our card component renders, the useEffect will run only once. The code inside of it will add focus to our div. Finally, we have to also actually make this div focusable. Right now it is not, because a div is not an interactive element. So we go down here to the div, and after the ref attribute, we add a tab index attribute. On this tab index attribute, we set the value -1. With all of this new code, our div here will now be focused as soon as we click the question mark button and it turns into a monkey face. I have written some focus styling inside of our CSS file that will now apply to this div, but unfortunately, this styling is not picked up in my recording. So I would like to ask you to now, on your own, pause the scrim and run the code, click the button to see the difference between the focused div and the not focused div. Please go ahead and do that now. All right, now I will run the code as well and walk you through the result of our refactoring here. As soon as I click this question mark button, the focus is now on this div here. The background has changed to white, the text color is dark, and there's a box shadow on it. Hopefully you saw the same thing when you ran the code. There is one last thing that I want to make completely clear here. The styling that I have added is just for you to be able to see that we are focusing this element. It is not important when we use focus as an accessibility tool, since the whole purpose of this focus is to guide assistive technology as to what it should read aloud to the users who cannot see the screen. So you don't have to add any special focus styling in order for this to work. You have learned a ton of new things in this scrim, and in the next scrim, we'll return to our memory game so that you get a chance to practice this by implementing it to our GameOver component. See you there. Okay, it is now time for you to put everything that you've just learned into practice. I hope that you're ready because we are going to jump straight into your next coding challenge. I want you to use the useRef hook, the useEffect hook, the .focus method, and the tab index attribute to add focus to this div as soon as the GameOver component renders. I then want you to actually play a memory game to check that your code is working. I also have an important warning for you here. You have to use keyboard navigation to see your browser's default focus styling on the div. I did not write any CSS this time that adds specific focus styling, so all you'll see is the default styling. In Chrome, that is a blue outline around the focused element. But, and this is the important part, this blue outline in your Chrome browser or whatever browser you're using is only visible when you navigate using your keyboard. If you use your mouse to click the very last memory card, turn it, and make the GameOver component appear, you won't see any focus styling. So please use your keyboard. Now go ahead and pause the scrim, work on this challenge, and I'll be back with you in just a second to show you my solution. Alright, I hope that went well. Let's do this together. We need the useRef and useEffect hooks from React, so the first thing we have to do is, of course, to import these hooks. We do that up here at the very top of the file by saying import, then curly braces because these are named imports, and then we import our hooks from React. Inside of our component, we can now create a new const. I'm going to call this one divRef. If you chose a different name for this variable, that's completely fine. We set our divRef equal to useRef with the initial value of null. Now that we have this divRef, we can add it down here on the div as the value of a ref attribute. Next, we'll create a new useEffect. It has an empty dependencies array because we only want this code to run once when the component first loads. Inside the useEffect, we want to add focus to our ref here, and we do that by saying divRef.current to access the current property on our ref, and then chain the focus method onto it. Finally, we want to add a tab index right here on the div after the ref, so we say tab index, and give it the value -1. And that should be it. Now it's time to run the code and check that everything is working. I am just going to speed through this game so you don't have to watch me do it in real time. Okay, we now have one card left to turn. As you can see, my mouse is up here, and I'm going to use my keyboard, as I've done all the way through, to turn the last card. So I hit enter, and on my screen I can see a blue outline on the div. I know that you cannot see this one. It is not picked up in the recording, but hopefully you saw it when you played the game on your own. What you will be able to see, though, is that when I now hit my tab key just once, The focus is now on the Play Again button, and this is a sign that the focus moved one level down from the div to the button. If you managed to take in all of this new information and implement it into our memory game, you should be very proud of yourself. This is a super important accessibility improvement that we just made here. Our next big task will be to work on the error handling in our game, so when you're ready to tackle that, I'll see you in the next scrim. In the very beginning of this course, we worked on the start game function that makes a call to the Emoji Hub API to fetch the emojisData that we are rendering on our memory cards. In this function, we use the try-catch syntax to catch potential errors. Here in the try block, we check if the response is okay, and if not, we throw a new error, which is then caught down here in the catch block and console logged. This is all very good because we are preventing our app from just crashing if the data fetching fails. But so far, we are only logging an error message to the console, meaning our users don't get any information about what is going on. To illustrate just how bad the user experience is right now, let's throw a new error inside the try block. Up here, at the very top of the block, before we do anything else, we simply say throw new error with the same syntax as we're using right here. So we can copy paste this line of code, paste it in here, and I'm just going to change the error message. We are throwing an error. Let's run this new code to see what happens. We click the Start Game button, we get an error message in the console, and that is the error message that we just created here when we threw the error, but in the UI, nothing happens. The user doesn't even know that there is an error. To them, it might just seem like we wrote a crappy app that simply doesn't work. That is, of course, not good enough. What we want to do instead is to create a new component displaying an error message, and we'll render this component in case anything goes wrong when we try to fetch data from the API. I have taken some screenshots here so that I can show you what we are aiming at. As you might remember, this is what the form component looks like in our finished memory game, so just a little teaser, we'll be building that one soon. But the important part now is that if we click the Start Game button and something goes wrong when we try to fetch data, this is what will happen in the UI. We'll render a component saying, sorry, there was an error. And we'll even give the user an opportunity to click a Restart Game button to take them back to the form where they can try again and see if things work now. To achieve all of this, there are several things that we need to do. We need to create this new component, of course, and we also need to write some code here inside of the app component so that we can control when to display our new error component. In the next scrim, we'll focus on the latter and write all the code necessary for our yet to be created error component to render correctly. See you there. In order for us to be able to render an error component in case the data fetching fails, we need to save some information in state that tells us if there is an error or not. When our memory game first renders, what we see in the UI is the form component. At this stage, we haven't yet made an attempt to fetch any data, so we can safely assume that there is no error either. As soon as we hit the Start Game button, this code here inside of our Start Game function runs. We'll then either get some emoji data back that we can work with, or we'll get an error. In case of an error, the code inside of our catch block is what will be executed. And here we want to update the error information that we're saving in state to say that, yes, now we do have an error. When that happens, we want to render this error component that I also showed you in the previous scrim. This component has a Restart Game button on it, and in this case, restarting implies that we again update the error information in state to say, no, we no longer have an error, and that we send the user back to the form component. So this is the logic that we have to build into our app. And surprise, surprise, now it is time for you to turn all of this into code. In step 1 of this challenge, I want you to create a new state variable called isError with a corresponding setter function and initialize it to false. In step 2, I want you to go inside of the catch block in the start game function and set isError to true. In step 3, I want you to create a new function at the bottom of this file. You should call this function resetError, and what it should do is that it should set isError back to false. In step 4, you should go inside of the try block in the start game function and throw a new error with a custom error message, and you should also log isError to the console. Finally, in step 5, I want you to run the code to check that everything is working as expected. Because this involves writing code in various different places in the same file, I have given you a bit of help. As you can see, I've written comments saying where each step is to be solved. So step 1 code here, step 4 code below here, and so on. So you can see we have step 4 here in the try block, step 2 here in the catch block, and finally step 3 down here above the return statement. I do also have a little warning here. We won't be able to test the resetError function at this stage since we're not yet calling it. So don't worry about that bit. For now, what I want you to test is that you are successfully flipping the isError state variable to true when you throw an error inside of the try block. Okay, pause the scrim now, jump into the code and solve this challenge, and return back to me to see my solution. All right, I hope that went well. Let's do this together. We'll start by initializing some new state here. As always, we do this using a const. We open up the square brackets and we call the variable isError, and then we create the setter function setIsError. This should be equal to useState, initialized to false. That was part 1 of the challenge done. Step 2 is to go into the catch block right here and flip our new state variable from false to true. So we run the setter function setIsError and set the value to true. That was step 2 done. In step 3, we should create this new resetError function. All the way down here at the bottom of the file, we create a new function called resetError. And in here, we run the setIsError function again, this time setting state back to false. And that was step 3 done. In step 4, we are to throw a new error inside of the try block. Right here. So we say throw new error and pass in a custom error message. I am now throwing a brand new error. That's going to be my custom error message. We also want to log isError to the console up here. So we say console log isError. And that was step 4. All we have left now is to run the code and check that everything is working as expected. So we can safely delete the last part of our challenge text here. Let's run the code. Down in the console, we saw the word false. In fact, let's just open up the console so we can actually see what's going on here. We get false locked to the console because isError is initialized to false. Now when we click our Start Game button, then we should immediately get an error because we are manually throwing an error inside of the try block. And in the console, we see the custom error message. I am now throwing a brand new error, and we see that isError is flipped to true. Excellent. We now have all the logic set up that we need in order to render an error message to our user if something goes wrong with the data fetching. In the next scrim, we will build this component and render it to the UI, so when you feel ready to tackle that one, I'll see you in the next scrim. Okay, I hope that you're ready to flex your coding skills, because I'm about to give you your biggest challenge so far in the course. You already know what we are aiming for, an error component that is rendered if the data fetching fails, with a button on it that we can click to reset the error and go back to the form. So without further ado, let's just get going. Here it is, your mega challenge. Read through each step carefully. I have described everything you have to do and given you a hint as well. It is a mega challenge, and I understand if you feel a bit overwhelmed right now, but trust me, if you've been following along and have solved the previous challenges, then you've got what it takes to solve this one too. One last thing before I leave you to it. Be aware that we are still throwing an error right here inside the try block of our start game function. We need this error to render the new ErrorCard component that I'm asking you to create. But just in case you want to try out other things along the way and actually start a memory game, make sure to comment out this line of code. Alright, pause the scrim now. Give this your very best shot. Remember to check out the hint if you ever get stuck, and return back to me to see my solution. So I hope that went well. Let's do this together step by step. We'll start out by creating the new file for our ErrorCard component. As you very well know by now, you won't be able to see what I'm doing on my screen, so I'll just speed up and get this file ready for us. Inside of this ErrorCard.jsx file, we'll set up the basic syntax for our new component. We make a default export here, as we've done so many times before, and inside of the component, we want a return statement. We know that we want to return a div wrapping around two p tags and an instance of the regular button component. In order for us to actually render this regular button, we need to import it as well at the top of the file. Now that we have our elements in place, we can go back to the app and simply do some copy pasting to get the content in here as well. Everything is written out for us already here in step 1, so once again, I'm just going to speed up and do some copy pasting. Now that we have all our content pasted in here, I believe we are done with step 1, so let's go back and look at the next step in the challenge. In step 2, our job is to style the elements in this new component. Once again, I'll speed up and do some copy pasting of our strings here so that you don't have to watch me do everything in real time. So we now have class names on our div and on our two p tags, and we are done with step 2. In step 3, the only instruction I gave you was to make our ErrorCard accessible. Hopefully you figured out that what you have to do here is exactly the same as what we did in the GameOver component. Inside of our ErrorCard, we need to start out by importing the useRef and useEffect hooks from React. Then inside of the component, we create a new const called divRef and set it equal to useRef and initialize it to null. Then we add this new divRef to a ref attribute on our div right here after the class name. Next, we create a useEffect with an empty dependencies array because we want it to only run once when the component first renders. In here, we take the divRef and we access its current property, and on this one, we chain the focus method. Finally, we add a tab index with the value of -1 to our div. Now our ErrorCard is accessible in the exact same way as our GameOver component. Let's go back to the challenge again to see what we have to do next. Now it is time for us to actually render this ErrorCard, so we of course need to import it first before we can do anything else. We do that up here at the top of the file together with all our other imports. Then we scroll down to the very bottom of the file, and we render this ErrorCard component below the memory card whenever isError is true. So all we have to do here is say isError, and then use the logical AND operator and render an instance of ErrorCard. That was step 4 of the challenge done. In step 5, we are to pass the reset error function through props to the regular button in the ErrorCard and use it on the onClick event handler in the regular button component. So once again, we'll scroll down to where we're rendering the ErrorCard. Then we pass a prop here called handleClick with the value reset error. Inside of our ErrorCard, we want to receive this prop and then pass it one level further to the regular button. Inside of the regular button, we are already receiving this handleClick prop up here and using it down here on the onClick event handler. So that was it for this step of our challenge. I can no longer remember the number of it, but it was step 5. In step 6, we have to refactor the conditional rendering of the form component so that it is not rendered when there is an error. So down here inside of the return statement, we want to add an extra conditional check here. The form should render when the game is not on and when there is no error. So we use the exclamation mark and is error, and of course the logical AND operator. That was it for step 6. The only thing we have left to do now is to run the code and check that it is working. So let's delete this last part of the challenge and then just cross our fingers and hope that we didn't miss anything here. When we click the Start Game button now, what we should see is our new error component. And we do! The component is rendered just as we wanted to, and the form is gone. Now when we click the Restart Game button, we should be taken back to the form. Let's hope that this part works as well. And it does! Amazing! This was a huge challenge. And I want to say here that no matter if you manage to solve all of it, or parts of it, or none of it, you should be proud of yourself for even trying. Everything that I asked you to do here was something that we have done elsewhere in the code, but that does not make a challenge easy. So give yourself a huge pat on the back, be proud of all the hard work you put into this, and remember to take a break whenever you feel like you need it. When you're feeling refreshed, move on to the next scrim, where we will take the first steps towards making our form component an actual form. See you there. Throughout the entire course, we have lived with this rather poor excuse of a form that contains nothing but a button. As you probably remember, our finished form should also contain 2 select menus that allow the user to select an emoji category and a number of memory cards. In order to make this change, there are 2 things that we have to do. We have to, of course, build the actual form elements, and we also need to do some refactoring here in our app component so that we can use the data that we get from the form instead of hard-coded values when we fetch EmojiData and render memory cards. We do have quite a lot of work to do here, so we'll break it down into multiple scrims and take it step by step. The first thing we'll focus on is to refactor the relevant parts of our app component. Right now, we have hard-coded values in 2 places. Here, in the URL that we use to make the fetch request to the Emoji Hub API. As you can see, the last bit of the string here is the hard-coded emoji category, animals and nature. We are also hard-coding a value down here inside this for loop, namely the number 5. It's been a very long time since we wrote this function here, so I'm just going to quickly remind you of what it is we are actually doing. In the for loop here, we are generating random numbers here on line 65, and then we push them to the random indices array here inside of the if statement. Finally, we are returning that array down here, and we're using this return value up here in the getDataSlice function. In this function, we are using the .reduce method to iterate over the array of random numbers returned from the getRandomIndices function, and then we use each of these random numbers here as an index to get a random element from the data that we are receiving as a parameter. All in all, this creates a new array called DataSlice, which we're then returning from the getDataSlice function right here. So the essence, the important thing here is that the length of this random indices array is what determines the number of memory cards in our game. We have hard-coded the number 5 in the for loop, which gives us 5 random unique emojis, and in the end 5 emoji pairs, meaning 10 memory cards, because we're duplicating each emoji. Okay, so now we have sort of an overview of where we need to refactor our code. And I think that you are ready for a new challenge. In step 1, I want you to go up here to the very top of the component before the state variables and create a new variable called initial formData. You should set this variable equal to an object with the key value pairs that I have written out right here. In step 2, I want you to create a new state variable called formData with a corresponding setter function and give it the initial formData that you just created as the initial value. In step 3, I want you to update the URL in the fetch request to use the category saved in formData instead of the hard-coded category. And in step 4, I want you to update the for loop in the get random indices function to use the number saved in formData instead of the hard-coded number 5. Finally, in step 5, I want you to run the code and start a game to check that your refactored code is working. You should still get exactly 10 memory cards rendered to the mini browser. And in case you're struggling to figure out how to do that, then take a look at the hint that I have written out for you down here. So pause the scrim now, jump into the code and try to solve this challenge, and I'll be back with you in just a second to show you my solution. All right, hopefully you managed to do that just fine. Let's go through this together now. We'll start by creating the new variable initial formData up here as the very first thing we do inside of the app component. We do that using a const, and then the name of our variable initial formData, and we set this equal to an object, so we need our curly braces. Inside of the object, we want two key value pairs. The first one should be category, and this one should have the value animals and nature as I've written out right here. So I'm just going to copy paste this one. The second key should be called number and have the value 10. And that was step 1 done. In step 2, we are to create a new state variable. I'm going to do that right here above the rest of our state variables. So we say const, open up these square brackets, and then we say formData and create the setter function setFormData. This should be equal to useState with initial formData as the initial value. Now we're done with step 2. In step 3, we are to change the URL here to no longer have the hard-coded category animals and nature and instead use the category that we just saved in the formData. So the first thing we need to do here is, of course, to change this from a string to a template literal. Then we delete the hard-coded category and we use the $ and curly braces to add in the category that we have saved in our formData. That was it for step 3. In step 4, we'll have to go down to the get random indices function and change this hard-coded number 5 to the number that we have saved in formData. Though if we simply say formData.number, we won't get 10 memory cards rendered to the mini browser, we'll get 20 memory cards. Because remember, down here in the get emojis array, we are duplicating each emoji in the data so that we get emoji pairs. Therefore, we need to ensure that we get half as many unique emojis as the number of memory cards that we want to render. It might sound more complicated than it actually is, because all we have to do is to divide formData.number with 2. I don't think that the parentheses that I set here around this mathematical operation is actually necessary, but I like to have it here because I think it improves the readability of our for loop. Finally, all we have left to do now is to run the code and check that everything is still working. So we start a new game and hopefully we will see 10 memory cards just as before, and they will still come from the category animals and nature. We definitely have 10 cards, and these leaves here definitely look like something that comes from animals and nature. Great, we have now set the stage for the rest of the work we need to do here. Our app is ready to consume the form data, and in the next room, we'll start building the actual form elements. See you there. In this scrim, we'll create two select elements right here inside of our form component, one for the emoji category and one for the number of memory cards. For now, we will hard code these form elements because I think it's a lot easier to understand how to work with forms in React when we have everything in one place and can really see that the select menus and their options are in fact one coherent form unit, so to speak. Before I give you this scrim's challenge, there are a couple of small changes that we need to make to this component. For styling purposes, we need to wrap the entire form in a div, and this div should have the class name formContainer. We also need two new divs inside of the form element that will be wrapping around one select element each. On these two divs, we have the class name formInnerWrapper, and again, this is merely for styling purposes. So with these new divs in place, I believe that you are ready for your next challenge. Here is what I want you to do. In step 1, create two new select elements, one for the emoji category and one for the number of memory cards. Each select menu should have a name, an ID, and an onChange event handler. And I have, of course, written out the values that I want you to use on this name, ID, and onChange right here as part of step 1. In step 2, you should create 5 option elements inside of each select element using the values that I have written out right here as part of step 2. In step 3, give each select element a label describing the select menu. This was the first half of the challenge, and inside of the app component, there are 2 more steps. In here, I want you to create a new function called handleFormChange. This function should receive the event as a parameter. Inside of the function, I want you to then use the event to get the name and the value of the selected option, and for now, simply log name and value to the console. Finally, in step 5, you should pass this handleFormChange function as the prop handleChange to the form component, and remember to also receive this prop inside of the form. We do, of course, also need to test this new code. I realize now that I did not write that as part of the challenge, so give me a second while I fix that. Here it is, step 6. Run the code and select some options in the form to test that your code is actually working. Let's go back to the form, where you will start with all of this hard work. If you feel a bit rusty on how to create select menus, Google is your friend. There are loads of resources out there, so please do use those if you get stuck. Pause the scrim now, give this your best shot, and I'll be back with you in just a second to show you my solution. All right, I hope that went well. Let's get to work. We'll start right here inside of the first div by creating the select element for our emoji category. First of all, we need the actual select tag. On this select tag, we need a name and an ID, both with the value category, and we need an onChange event handler with the value handleChange. The select element for the number selection should look very similar to this one, so I am now going to simply copy this one, paste it in down here in the div, delete this comment that we don't need anymore, and change the value category to number. That was it for step 1. In step 2, we want 5 options inside of each select element. Again, we'll start up here with the category. We'll create an option. And on this very first option, we want the value, animals, and nature. We also need to write something here between the opening and closing option tag, and that is what will actually be rendered when we open up the select menu. So here we simply write animals and nature again, but in a more human-friendly way, without the hyphens between the words. And now I'm simply going to speed up and fix the 4 remaining options here in our first select element. Here we have our 5 options: animals and nature, food and drink, travel and places, objects, and symbols. Let's do the same thing down here, create 5 option elements, passing in the correct values. Once again, I'll speed type so you don't have to see me do it in real time. Here we have them, options with the values 10, 20, 30, 40, and 50. And that was step 2 done here. Finally, we are to set a label on each element describing what it is we are selecting. So we use the label tag here. And on this first one, I'll say select an emoji category. Now, in order for this label to actually be connected to the select menu below, we need to use the HTML4 attribute and give this the same value as we set on the ID of the select element. And once again, we do the same thing down here. On this label, I think we should say select the number of memory cards. And once again, we'll give it an HTML4 attribute with the same value as the one we set on the ID of the select element. That should be it for the challenge here inside of the form component. In the app component, we'll now create this new function called handleFormChange. This function should receive the event, and now that we are receiving this event, we can use it to access the name and value of the selected option. We do that by saying e.target.name and e.target.value. The name that we will get here is the name that we are setting on our select elements. So category on the first one and number on the second one. The values that we are getting with e.target.value come from the option elements. So this one, for instance, the second option in the category select element has the value of food and drink. So if we click the select option here, we'll get the name category and the value food and drink. Back in our app component, our task was to log these two to the console. I will create a template literal here so that I can create one single console log with the name first, then a colon followed by the value. That was it for step 4. In step 5, we should pass this new function as the prop handle change to the form component. We do that right here, where we are rendering an instance of form. So we say handle change and give it the value handle form change. With this extra prop added, our formatting is getting a bit crazy here. So let's just clean that up. Nice, this is a lot more readable. The only thing we have left to do now is to receive this prop inside of the form component. Up here in the function declaration, we can simply add handle change right here after the handle submit prop. Okay, now it's time to test our new code and see how it works. We run the code, and here we have a form. Excellent. I will now click the first select menu here to select an emoji category. I know that you are not able to see the displayed options in the recording, but hopefully you did this on your own and tested the code so that you know what it looks like. I'm now clicking the option food and drink, and down in the console, we can see that that is exactly what we're logging, category food and drink. Let me just select a number of memory cards as well. I'll go with 40, and in the console we can now see number colon 40 logged out. So our select menus, including labels and options, are rendered correctly inside of the form component, and our handle form change function is also hooked up correctly with the form and tracking the selected options. We do, of course, need to do something more than just logging the name and value to the console here inside of the handle form change function, since we want the user's selections in the form to actually be saved in our form data in state. This is exactly what we'll be tackling in the next scrim, so when you feel ready to move on, I'll see you there. A few scrims ago, we created this formData state variable, and we gave it the initial value of initial formData, that is the object that we created up here, containing the two keys category and number and their corresponding values. In this scrim, our job is to update the code down here in our handle form change function to use the setter function from the formData state variable to replace the initial value of formData with the actual selections made by the user in our form. The handle form change function here is handling changes in both of the select elements in the same way as the formData state variable is to keep track of and manage the selections in both elements. This implies that we cannot hardcode anything related to the formData in this function because we simply don't know in advance which select element the user is interacting with when the onChange event handler on a select element is triggering the function. Instead, we have to rely 100% on the information that we can retrieve from the event that we are receiving as a parameter. Let's run the code that we have right now and select some options so that we can inspect what it is we are logging to the console and how we can use it to update our form data. I will now select food and drink as the category and 20 as the number of memory cards. As you can see, this e.target.name is clearly category in the first select menu and number in the second. These two values are the exact same as the ones we are using up here on the initial form data object. This tells us one important thing, and that is that when we want to update the form data in state, we can use e.target.name as a key in the form data object. And as I'm sure you've already figured out, we can then use e.target.value as the value set on this key. Now that we have outlined a strategy here, it is time for your next challenge. When the handle form change function runs, you should update form data to store the most recent selections made in the form. Form data should always be an object with two key value pairs. You should use e.target.name as the key and e.target.value as the value. I do have a hint for you as well. Remember to keep track of the previous state, and the object spread operator can help you with this. Pause the scrim now, jump into the code and solve this challenge, and return to me to see my solution. Okay, I hope that went well. Let's do this together. I'll start by simply deleting this console log because we don't need it anymore. Now we can run the setFormData setup function. And in here, we need a callback function so that we can keep track of the previous state. I'm going to go with preFormData as the name of our parameter here. And now inside this callback function, we want to return a new object. Though we cannot just write curly braces like this and then start creating our object, because as soon as we add curly braces after the arrow in an arrow function, JavaScript perceives this as the opening of a function body. Therefore, we need to wrap our object here in a set of normal brackets if we want to be able to write our object without actually opening the function body and using the return keyword. We know that we have to keep track of the previous state, and the reason we have to do this is actually quite obvious. The user can only ever make a selection in one select menu at a time, meaning we have to keep track of what was most recently selected in the other select menu, the one that we are not dealing with currently. We can do this using the object spread operator with these three dots and then spread in the preform data. Now we want to use e.target.name as the key in this updated object. But as you can see, JavaScript is not happy with us right now. There's clearly something wrong with the way that we are trying to use this e.target.name as the key. The problem is that we cannot just use a property on the e.target object as the key, as we're doing right here, without wrapping this in square brackets. But if we do that, the red squiggly lines are gone, and instead it has moved out here to the closing curly bracket, and that is simply because we have not yet declared a value on this key. So let's do that now, e.target.value, and this should be it for this challenge. When we run this code now and make some selections in our form, we should see that we are able to customize our memory game. Let's give it a shot. I am going to go with food and drink, and I want 30 memory cards, I think. So now when I start the game, hopefully we'll get 30 memory cards, and on these cards we will see food and drink emojis. Okay, we definitely have a lot of cards. I believe there are exactly 30 here. Let's turn the first one. And this is a cucumber. Let's turn a few more to see what this food and drink category has to offer. Some sort of cookie, a shrimp, I think, and a beer. Well, cheers! What a wonderful coincidence that we found a beer now that our form is working. The only thing we have left to do now in this course is to refactor our newly created form to use reusable components as the form elements instead of all the hard-coded elements that we have right now. When you are ready for this big refactoring, I will see you in the next scrim. Do you remember this data.js file? It's been lying right here throughout the entire course in our data folder, waiting for us to reach the point that we're at now, where we are to refactor the select element in our form from hard-coded JSX to reusable React components. Before I say anything more, I would like you to take a good look at this data on your own. Pause the scrim now, take a second to familiarize yourself with the code, and return to me when you're done. Okay, as I'm sure you can see, the data that we have here corresponds with the information that we attached to the select elements in our form, and therefore also to the form data that we are saving in state. The data variable itself is an object with two key value pairs, and on each of these keys, the value is an array of objects. Now that we want to replace the hard-coded select elements with reusable components, this is the data that we'll use to create those components. Inside our form component, our goal is to get rid of these two divs here, inside of which we are currently rendering our select elements, and instead render one single instance of a new select component. Just to get us started, I have actually already created a file for this new component right here in the components folder. Though as you can see, there's not much going on in here right now. On line 1, we are importing the data object that we just looked at, and then we are exporting a functional component called select that receives a prop called handle change. Back in the form component, we are importing the select right here, but currently we are not rendering it. In the challenge that I'm about to give you, I want to allow you to focus only on the refactoring itself, so I'll now make a couple of small changes to this form component here, just to make your life a bit easier. Okay, let's quickly walk through this. Right here, inside of the form, we are now rendering an instance of the select component, passing it the prop handle change. Below this new select component, I've commented out the divs that we no longer want to render. We'll leave them here for now so that we can reference them when we solve the challenge. I've also added a p element right here above the form but inside of the div. For now, I won't say anything about why I did this, but we will discuss this later in the scrim. Okay, with these small changes in place, I believe that you are ready for your next challenge. In short, your job in this challenge is to recreate our select elements by writing some code here inside of the select component. In step 1, I want you to use a combination of the object.entries method and the .mapArray method to iterate over the data object that we are importing, and then create a div element similar to those that are currently commented out in the form component. Inside the div, there should be a label and a select element, but for now, leave out the option elements. We'll be creating those in the next scrim. In step 2, you should store all of this in a new variable called selectL, and then return this variable at the bottom of the component. I've provided some hints for you as well, and a warning. Make sure to take a look at those if you find yourself struggling. Pause the scrim now, work on this challenge, and I'll be back with you in just a second to show you my solution. Alright, I hope that went well. Let's do this together. The first thing we'll do is that we'll turn our data object into an array. We do this with the object.entries method, passing in the data here inside of the brackets. This gives us an array of arrays instead of an object with key value pairs. Now we can chain the .map method onto this array to get access to the nested arrays. Inside the map method, we want a callback function. For each iteration inside of the .map method, we'll be looking at an array. And just as we're doing up here, where we are destructuring our props object directly when we receive the prop, we can also destructure the array right here when we receive it as a parameter. We do this by adding square brackets, and then we have to come up with names for the two items we have in our array. The first item is equivalent to a key in our data object, and the second is equivalent to the value on that key. So I suggest that we call these items key and value. Inside the callback function, we want to return a div similar to the one that we had in the form component. So I'm now going to simply copy paste one of those. Now we have a skeleton in place here, and the first thing we can do is to delete our option elements. Next, we have to do something about our hard-coded values. In 3 places here, on the HTML4 attribute and on the name and ID attributes, we're hard-coding the string category. That is, of course, not going to do us any good now, so we want to replace this with the key from our destructured array. We also have to do something about the text content on our label here. Hard-coding a label saying select an emoji category won't work either, so once again, we'll use the key from our destructured array. Finally, we need to set a key on the div, and surprise, surprise, the value of this key will be key. Now, just to be completely clear, every time we use the value key, what we'll get here when this renders to the mini browser is either the string category or the string number, which are the keys on our data object. This was step 1. In step 2, we are to store all of this new code in a variable called selectL, and finally return this selectL down here at the bottom of the component. We do that inside of curly brackets wrapped in empty opening and closing tags. This should be it. Let's run the code and see how this went. Very good. We have our P element up here reading customize the game by selecting an emoji category and a number of memory cards. Then we have our now rather generic label text, select a category and select a number. We have our select elements with no options right now, but that was part of the original plan, so don't worry about that. Now, I did promise to explain to you why I want this P element here. And I actually think it is quite evident now that we see everything in the mini browser. Our labels have become so generic now that we can't write individual labels on each select element, that I think we need this explanation in the P tag to really understand what it is we're selecting. If you managed to complete this one all on your own, you should be really proud of yourself. This was not an easy challenge with all of the things we're doing up here. Chaining.map onto the object.entries method, and then destructuring an array when we're receiving parameters and so on. So great job. In the next room, we'll build an option component so we can get our form back to a working state. So when you're ready for that, I'll see you there. Due to the refactoring that we did in the previous scrim, where we replaced the hard-coded select elements with the new select component, our form is, as you know, broken because there are no options to select from here on our select menus. In this scrim, we are going to fix this by creating a new option component and rendering an instance of it inside the select component. Once again, I have done a bit of work in advance to help you get started. I have created an option.jsx file in the components folder, and here in the select component, we are now rendering an instance of this option component right here inside the JSX select element. To this new option component, we're passing this prop value array, and the value of this prop is the value that we get up here from our destructured array. The option component itself does not have much to it right now. We only have the basic syntax for our new component, and we are receiving the prop value array. It will now be your job to finish this component so that we can get our form back to a working state. In this challenge, I want you to iterate over the value array that we're receiving as a prop and create an option element. You should store all of this in a new variable called optionL and return this variable at the bottom of this component. I have some hints for you as well. If you're not really sure what to do with this value array or what it actually is that it is containing, then take a good look at the select component and the data file to understand which values it holds and how you can use it. You can use a ternary operator to conditionally set the text content on the option element. And the last hint, remember to set a key on the option tag. All right, pause the scrim now, give this your very best shot, and I'll be back with you in just a second to show you my solution. Okay, I hope this went well. Let's do it together. Our task here is to iterate over the value array and create some new JSX. So let's start out by saying valueArray.map. Now, to understand what it is that we're actually iterating over, let's take a quick look inside the select element. Here, on the instance of the option component, we are passing the value that we got from destructuring the array up here in the parameter of the callback function. As we saw earlier, the key from this destructuring was, let's go into the data, the keys on our object, category and number. So when the item that we call key in our destructured array is the keys in our objects, then the item that we chose to call value is, of course, the values set on these keys. So when we are iterating over the value array inside of our option component, we are iterating over an array of objects back in the option component. We can now go ahead and directly destructure these objects that we are mapping over. We start with regular brackets, then we add curly brackets, and then we type out the two keys that we have available on these objects, name and value. Now we can finish our arrow function and start creating our option element. The tricky part here is to figure out how to use the name and the value from our destructured object. We know that an option element needs a value attribute. And if we go back and look at our data, we'll see that the value on our objects, both here on the category objects and down here on the number objects, are exactly the value that we want to pass to our value attribute. So on the value attribute, we say value. Now the text content that we want on our option is a bit more tricky. Let's go back to the data file again. On the category select menu, we want the name here to be the text content that we are displaying in the UI, but down in the number, we have no name. We simply have the value, and that is because here the name and the value are identical. There's no difference between 10 and 10, but there is a difference between animals and nature, written in this human-friendly way with a capitalized A and spaces between the words, and this less human-friendly way with a lowercase a and hyphens instead of spaces between the words. So back in the option component, we need to use a ternary operator to conditionally set either the name or the value as the text content. The condition that we want to check for is if the name exists or not. If the object that we are currently iterating over comes from the numbers array, then there is no name key. And in that case, the variable name here will be undefined, meaning it will evaluate to false. So we can ask if name evaluates to true. And if it does, we want to use the name as the text content. And if not, we'll use the value. Finally, we want a key on the option element. So let's go ahead and add that one here. We know by now that the name can be undefined, so we cannot use name as the key. The only thing unique here is the value. Now finally, we have to store all of this in a new variable called option L and return this variable at the very bottom of the component. And this should be it. Let's get rid of the challenge text and run the code to see how we're doing. Look at that! We have our options back in our select menus. Let's start a memory game to check that they are actually working. I think I'll take travel and places this time. And I want 20 memory cards. All right, look at this. We have 20 memory cards. Let's turn this random one to check that there are actually travel and places emojis on the backside. It seems to be right. We got a clock, some kind of building, maybe a hospital, a sun, a spaceship. We got a church and a bank, I assume. Fantastic. This means that we are now more or less done building this memory game. There is just one last thing that we have to do inside of our form component, and it all has to do with our good old friend accessibility. So when you are ready to write your last pieces of code and wrap up this course, I'll see you in the next scrim. When our memory game first loads, what we see in the menu browser is the heading, memory, and the form component here. At this stage, we are all good when it comes to accessibility. Both of these elements are part of the DOM from the very beginning, and assistive technologies therefore know that the form is there and will let the user know as well. Though we also have stages in our game where the form appears in the DOM and in the mini browser out of nowhere. This is the case when we click the buttons that we have in our GameOver component, this one here, and the button in our ErrorCard component, this one here. The functions that run when we click any of these two buttons make the form reappear. And when it does that, when it reappears like this, we are facing the exact same accessibility issue as with the ErrorCard and the GameOver components themselves, namely that assistive technologies will not announce the reappearance of the form to the user. By now, you know very well how to fix this kind of accessibility issue, and that is by programmatically adding focus to the form component when it renders. But there is an extra layer of complexity to it this time. You see, we only want to focus the form when it reappears, not when the game first loads and the form renders for the very first time. Programmatically focusing a DOM node forces screen readers to read this node aloud before anything else. And in our case, that means that the heading memory would be skipped if we focus the form on the first render. And we really don't want that. The heading is a part of our app that we want the user to know about. Therefore, we want to make the focusing conditional, and it will now be your job to write the code that does that. So here it is, your very last coding challenge in this course. I want you to create a new state variable called isFirstRender with a corresponding setter function and initialize it to true. Then I want you to identify where in our code we should flip isFirstRender from true to false and use the setter function to do so. It's somewhere in the app component, but I'm not going to tell you where because it's now your job to figure that out on your own. In step 3, I want you to pass this new state variable isFirstRender as a prop to the form component. Inside of the form component, the final 2 steps of this challenge is to conditionally add focus to the div on rendering when isFirstRender is false. Finally, I want you to test your code by playing a memory game, and there are a few rules I want you to obey to here. Make sure to navigate only using your keyboard. When the form first renders, you shouldn't see any change at all, but when it renders for the second time, you should see the default browser outline styling on it. Pause the scrim now, do your best to solve this challenge, and return to me to see my solution. Alright, hopefully you managed to do this just fine. Let's get to work in the app component. The first thing we'll do is to create this new state variable. I'm going to do that up here above the formData to make it the very first of our state variables. So we declare a new const, open up the brackets, and name our variables. Then we set it equal to useState and initialize it to true. And that was step 1. In step 2, I asked you to identify where we should flip isFirstRender from true to false. And actually, we have to do that in 2 places in our code. Both of them are in here in the start game function. If everything goes well when we make a fetch request to the Emoji Hub API and we get data back that we can render on our memory cards, then it's the code here in the try block that will run. So when we set our emojisData to be equal to the emojis array and we set isGameOn to be true, we also want to set isFirstRender to be false. This will ensure that when the user is done playing a memory game and clicks the Play Again button in the GameOver component, the form will be focused when it reappears in the DOM. But what if this code here in the try block never runs because our response is not okay? Well, then it's the code in the catch block that will run. And in this case, we know that the ErrorCard component will render, and from the ErrorCard, the user can also go back to the form to try to play the game. Therefore, we need to also set isFirstRender to false here. One final touch to step 2 of our challenge could be to make a small refactoring here. Obviously, we want to set isFirstRender to false no matter if we have an error or not, and we could do that in a finally block. The finally block is meant for this exact purpose, code that we want to run no matter what happened in the try and the catch sections. Now we are done with step 2. In step 3, we want to pass isFirstRender as a prop to the form component. We do that right here and say isFirstRender and give it the value isFirstRender. And just for the sake of readability, let's format this a bit better. Nice. Now we're done here in the app component, so let's go into the form component and finish the challenge. The first thing we'll do is, of course, to receive the prop isFirstRender. Now we want to conditionally add focus to the div here. To do that, we need the useRef and useEffect hook from React. So we'll import those and then use the same technique as we used on the ErrorCard and the GameOver components to add focus to the div. So we declare a div_ref variable that we set equal to useRef and initialize to null. Then we add this div_ref to the div. We create a useEffect, and inside of this, we access the div_ref.current and then chain the .focus method onto it. On the div, we add a tab index. And finally, we have to make sure that the focus method only runs when isFirstRender is false. The easiest way to do that is, in my opinion, to say !isFirstRender and then the logical AND operator. This means that if isFirstRender is false, the code after the $& should run. If isFirstRender is true, on the other hand, this code should not run. In case you struggled with this challenge and wasn't able to complete it on your own, I want to ask you to do step 5 on your own now. You won't be able to see the focus styling when I run the code because it's not picked up in the recording. So if you haven't already played a memory game as I described in step 5 and observed the conditional focusing of the form, please pause the scrim and do it now. All right, let's play a memory game together now. When the app loads, I see no focus styling on our form component. Now I'll start a game and speed through it. Here we have the GameOver component, which I can see is focused just as we want it to. I hit my tab key once to move the focus from the div to the button. I hit enter to play the game again. And now our form is focused. And we can be sure that users of assistive technologies will be informed of the reappearance of our form component. This was the very last challenge in this entire course. In the next scrim, we'll take some time to celebrate all the hard work that we did and to talk about how you could make this memory game your own to get even more practice working with React. See you there. Congratulations! You made it all the way to the end of this course and you built a super cool and fully accessible memory game. That is quite an achievement and you should be very, very proud of yourself. At this stage in a Scrimba course, what usually happens is that you see some crazy GIF with people or confetti or what do I know jumping around on the screen. Though I personally am really no fan of GIFs. On a bad day, GIFs can cause some level of motion sickness for me, and since this is my course, then I make the rules, so I decided to create an emoji story for you instead. My message to you is that you have done an amazing job. You probably fought hard at times, but even though some challenges might have made you feel dizzy, you powered through. And now you're on that space rocket, heading for the stars, and it is time to celebrate. We covered a lot of ground in this course. We worked with props in React. We passed and received those props as props have never been passed and received before. We work with hooks, more specifically with the useState hook, the useEffect hook, and the useRef hook. We built a form with select elements, and not only did we build that form once, we build it twice because we refactored our hard-coded form to a form made up by reusable React components. When it comes to JavaScript, we took a very close look at how we can handle HTML entities in our code. We used the destructuring assignment to destructure both objects and arrays, and we used the spread operator on both objects and arrays as well. We also made use of various array methods, the map method, the includes method, the find method, and the slice method. Last but not least, we work with randomness. We selected random emoji objects from the data we got back from the API, and we also shuffled the array of emoji objects to ensure that our memory card was displayed in a random order in the mini browser. Within the area of accessibility, we worked with 3 different aria attributes: the aria-label, the aria-live, and the aria-atomic attribute. Finally, we saw how we can use JavaScript's .focus method in combination with 2 React hooks and the top index attribute to programmatically add focus to an element and thereby making it accessible to assistive technologies. If you want to get even more out of this course, the best thing you can do is to make the memory game your own. I have several ideas to how you can do that. You could implement some sort of timer or counter that keeps track of either the time it takes the user to finish a game or the number of turns the user needs to take in order to find all the matching pairs. You could also refactor the React code to, for instance, use the context API, one of the more advanced React topics, or you could implement React Router and thereby replace some of the conditional rendering that we have going on inside the app component and instead render different routes. If you want to level up your CSS skills, you could redesign the entire app. You could give it a completely new layout or color scheme, or you could implement a light and dark mode switch, for instance. And finally, you could integrate a different API to get different motifs on your memory cards. These are, of course, just my ideas. You might have completely different ideas for how you could customize this memory game and make it your own. And all I have to say about that is knock yourself out. The more code you write, the better you get at coding. And one of the best ways to ensure that you're motivated to write code is to work on a project that you find fun and interesting. It has been a pleasure working with you, following along on your journey to become a front-end developer. My name is Ayo with the impossible last name Bovol. Feel free to reach out to me on the Scrimba Discord server or on LinkedIn. I hope to see you around in the Scrimba community anyway. Goodbye for now and happy coding!